Welcome to the DevOps on Google Cloud Platform course. This course has been designed to cover the basic aspects of what DevOps is, why it's important, and how we could deploy DevOps pipelines on Google Cloud Platform. During the course, we're going to be talking about what DevOps is, what a CI pipeline is, how to set up a continuous delivery pipeline. We'll go on and talk more about source code management on Google Cloud, as well as performing demos on App Engine, Kubernetes Engine, Cloud Build, Cloud Source Repositories, and other services around Google Cloud and DevOps. We'll be discussing specific features and functions that enable DevOps, but also provide development best practices and also enable developers to rapidly provision your applications in Google Cloud. We'll be discussing such features such as App Engine Security Scanner. We'll be talking about Kubernetes Federation. We'll also be performing a whiteboard on Kubernetes Engine to bring it all together. We'll also talk about service accounts and how to deploy a service account. We'll talk about infrastructure as code and walk through some demos on Cloud Launcher, which is now Cloud Marketplace, but also talk about Deployment Manager as well. Lastly, we'll wrap up the course with discussing different resources available to developers, but also we'll talk about certifications in Google Cloud for those that are interested in getting enabled and certified with the Google Cloud Platform. I'm really looking forward to working with you, and I hope you could join the course. So let's go ahead and get started. We have a lot to cover here. Welcome to the DevOps on Google Cloud Platform course. During this course, we're going to be covering DevOps and what DevOps is, and basically discuss how DevOps and Google Cloud complement each other. We're going to talk about the various facets of continuous integration, continuous delivery, and deployment. We'll then proceed on and talk about source code management. We'll talk about App Engine, and we'll walk through some demos on App Engine as well. And then we'll discuss what to use. Should we use App Engine or Kubernetes Engine? Again, the right decision for the right solution. We'll talk about what exactly a container is, and then we'll talk about what Kube Engine is as well. And then we'll go ahead and go through some demos on Kube Engine, and then talk about Federation, and then we'll do a whiteboard on Kube and how it all works together. Then I'll go through some tools that we're going to definitely want to know about when we're working with Google Cloud Platform. We'll talk about the Software Development Kit. We'll talk about Cloud Shell. We'll talk about Cloud Build, Container Registry, and Source Repositories as well. Then we're going to go ahead and move on to Cloud Tools, talk about Microservices, and what Cloud Functions is and how that can really play into your microservices architecture. We'll talk about Stackdriver, and we'll also cover an important aspect that's really important to know for developers is service accounts and how that can play into your application structure. We'll talk about what a cloud endpoint is and why that's important to know as well. We'll proceed on and talk about Deployment Manager, infrastructure as code. And then we'll move on to a Cloud Launcher demo. Then we'll talk about Qwiklabs and Qwiklabs, which are resources that are available for you to get practice on. And then finally, we'll go ahead and wrap up the course with talking about some other resources such as the DevOps webpage on Google Cloud Platform. We'll talk about Stack Overflow, which is a location on the web to get some help with development issues. We'll talk about the Diagram Asset Library, and then we'll go ahead and wrap it up with the different Google Cloud Platform certifications that are available. As far as prerequisites, this is really designed for IT professionals that already have some kind of foundation in Google Cloud, hopefully. And then having some DevOps experience will be very helpful. We'll, of course, be covering the basics of DevOps, but if you already have it, hopefully this will just reinforce what you already may know. As far as the course, it's not really the tutorial in the sense that we're going to walk through setting up every little detail, for example, but we'll be doing lots of demos to get you started. We'll be, of course, pointing you to additional resources and then move on to suggestions on other courses as well that you could take to enhance your knowledge in DevOps. Now, Google Cloud has some really powerful tools for deploying enterprise development pipelines and enhancing your DevOps experience. So let's go ahead and proceed on and get into the course and learn more about DevOps on Google Cloud. What is DevOps? So let's talk about what DevOps is and why it's so important. Essentially, I like to just sum up DevOps as more as a culture, a movement, an approach to managing your software deployments. But DevOps is really historically more of a melding of development and operations. It's a way that enterprise software is developed, and it's also a way that relationships are essentially handled between development and IT operations. The goal of DevOps is to really improve upon the relationship, to advocate better communication and collaboration between the two main business units. Now, it's also important to think of DevOps as a way to automate your software development as well. And generally, DevOps has historically been known as more of a concept and a cultural approach to collaborating together. But it really comes down to automation. And we'll talk more about that as well. And part of that automation is using what's called continuous integration, continuous delivery, and continuous deployment. Those are the three main facets of DevOps automation. Basically, this is creating a pipeline. A mainline is also another term you may hear of. But basically, DevOps is really a way to deploy software in an automated, efficient manner that is going to allow your organization, hopefully, to go to market quicker. Now, when we talk about continuous integration, this is a process where the developer working copies are shared to what's called a mainline, also known as a pipeline. Generally, this is done many times a day, depending on the organization, of course. The benefits are multifold. It creates efficiency, reduces risks, and also, again, removes manual processes. Remember, it's all about automation. Now, when we consider continuous delivery, this is a little different in the sense that it's the approach to get all those changes, whether they're feature changes, config changes, bug fixes, user requests, whatever, to place them into production safely, efficiently. The goal of continuous delivery is to reduce risk, but also provide better quality as well. Now, to sum this all up, we have continuous deployment. This is really an extension of CI where it's really trying to reduce any kind of manual processes and increase efficiencies. Now, again, the benefits should also work out to reduce basically errors and provide feedback quicker, lower risks as well. And this chart sort of sums up how this all really comes together. Basically, you have continuous integration, which is your code, build, and integrate phases. And then continuous delivery is a step off of that where it's actually released into production. And then continuous deployment is an additional part of that where you're maintaining those pipelines and those copies on your mainline, your pipeline, etc., to ensure efficiency, to reduce risk. And again, it's really about automating. So whether it's building, testing, deploying, provisioning, automation is really where it's all at. It should be the starting point in DevOps. Again, it really is about developers, testers, and operators working together in an automated fashion. Basically, with automation, it starts with essentially continuous delivery. And then basically what happens is, again, that code change is going to run through basically a bunch of automated tests. Then what should happen is that cloud infrastructure should then package everything up, basically the builds essentially, and promote them towards production, which is, again, through automated deployment essentially. Continuous delivery, in a nutshell, generally isn't exactly considered one of the easiest things to set up, but once it's done, it generally works. And it's all about getting that return on investment. Once again, part of all of this automation is, again, to provision to your environment the most efficient, risk-adverse, and also beneficial software. Now, when it comes to DevOps, it really comes down to trying to sum up continuous integration, continuous delivery, and deployment about as easy and efficiently as I can. And the best definition of this comes from Stack Overflow, I think. Continuous integration is really just meaning that the developer worker copies are synchronized with the shared mainline. Continuous delivery, again, is the next step where that continuous integration continues, but it's actually being able to put that solution, that fix, that release into production. And then deployment is, again, really the next step where you're automating everything after everything really passes quality assurance. Now, to sum it all up, DevOps is, again, development and operations. It's an enterprise software development phrase that's commonly used to describe agile relationships between development and operations. But as part of that, it really comes down to automation as well. Let's go ahead and move on. Let's talk about DevOps with Google Cloud Platform. Now, this module is really more of a summary of different tool sets and services we could use with Google Cloud. And we'll be getting into these services deeper throughout the course. So when it comes to DevOps with Google Cloud Platform, we want to be aware that Google has a robust and very well integrated DevOps strategy. It clearly enables developers to stay on the platform with tools such as Cloud Build, Cloud Repositories, and also other services that are sort of complementary, such as cloud storage or compute services, for example, such as Kubernetes Engine or App Engine. When it comes to config management tools, we have lots of choices as well. Again, we have Cloud Build, Source Repositories. We have other tools like Cloud PubSub, and then also big data tools such as Bigtable, BigQuery. We have other tools that can really extend out like Cloud Endpoints. Again, we'll talk about these services more in detail. When it comes to DevOps on GCP, we'll of course be talking about tool sets such as Cloud Source Repositories, Stackdriver, which is an integral part of monitoring your DevOps environment. We'll talk about the Cloud Software Development Kit, talk about Cloud Endpoints, essentially an API gateway, and of course, numerous other tools from Google Cloud Platform. But also, you could use third-party tools. For example, if you want to continue using your Chef, your Jenkins, whatever you're using, you can certainly tie that into your DevOps environment on Google Cloud if you so choose. Now, let's say, for example, we want to go ahead and basically use a GitHub. Now, we may be using GitHub or Bitbucket, for example. However, we decide that we don't want to use something that's publicly open or available, or we want to control our source code. Cloud Source Repositories is a really good tool to enable that. This is going to provide a full Git repository on Google Cloud Platform, and we'll talk more about that as well. Now, some other facets to consider is certainly around, for example, API gateway. The API gateway is called Cloud Endpoints. We'll talk about how that's an Nginx-based proxy. The endpoints are used to create essentially a web backend. Essentially, your developers are going to have an on-ramp to Google Cloud. You could use this for mobile and web, of course, and you could deploy this alongside App Engine, and it has a robust tool and library ecosystem. Now, some other notes on Cloud Endpoints. It supports Open Authentication 2.0. It is a Firebase Nginx proxy, and it is a distributed architecture. It supports data store, cloud storage, and also provides what's called task queues as well. And the goal of using this is to reduce your development cycle. And right now it's mainly Java and Python that's supported. App Engine. So App Engine is a platform as a service. It's fully managed. Basically, with App Engine, there's two deployment approaches. There's essentially a standard approach where you could deploy sandbox, and then of course you have essentially a premium version called flexible, and basically we would call it environments essentially. So we have standard and flexible environments. And the flexible allows you much more flexibility with your source code, and it would deploy as a container. We'll get into the differences with App Engine. I have a demo on App Engine as well. Very nice tool for developers, and it's one of Google's longest running services as well. So again, standard and flexible environments. There is an SDK kit available as well. Now, when it comes to basically development, one of the things to really talk about here is to go over to this website here, and let's take a quick look at it and talk about why we want to look at this before we start deploying anything on Google Cloud. Now, this page here, Development and Admin Tools, this is a page that sums up the tools that are available around development. We're going to cover most of these tools, for example, throughout the course. Mainly the tools I won't be touching on too deep will be, of course, like the APIs. That is more of a development focus than anything. But we'll be covering pretty much everything here, plus a little extra for that matter. So I would recommend you go to this page just to give you a little deeper dive. And if you're not familiar with any of these services, go over and take a look at what Cloud Tools is, or for example, Cloud Source Repository. And there's, of course, additional documentation on it. But we're going to be doing a lot of demos on these services and whiteboards for that matter as well. So let's go ahead and continue on. Now, as far as DevOps and Google Cloud, we know that Google has some well-provisioned services. So they have a robust ecosystem. And the reality is that this ecosystem is just getting larger and larger every year. Now, there's certainly options that can enable your development cycles to be efficient, easier, less risky. Remember, we could deploy pipelines on Google Cloud very simply. We could extend out from on-prem. A lot of options. We're going to really be getting into this when we get into the upcoming modules. So let's go ahead and move on and learn some more. Let's talk about continuous integration and what that is. And I'm also going to do a comparison between AWS, because I know a lot of folks are already familiar with AWS, and hopefully a little bit of contrast and comparison will help enable you to understand how powerful GCP really is. Now, let's talk about continuous integration first and just get an idea of what that is. So we sort of already talked about continuous integration initially. We know that that's the practice of taking essentially all the developer working copies and putting them in a shared mainline. Now, of course, we know what the benefits are as well. We want to reduce risk, remove those manual processes. But basically, when it comes to DevOps, generally organizations are going to want to, of course, migrate to the cloud, and Google, of course, supports this. So if you're already using on-prem services, you could certainly integrate with, of course, GCP services as well. Now, one of the things to talk about before we get into sort of some of the details of these services is I want to just do a quick little comparison between Google Cloud and AWS. Now, we know that if we so choose, we could be using a Bitbucket, repository, or GitHub. However, if we didn't want to use, for example, a code repository that's public, we could use something that's on Google Cloud. This, of course, provides some benefits. For example, additional privacy, additional security. Also, it localizes essentially our copies as well. And we could always fork over and bring in additional code when we need. So there's some automation and actually ease of use that could be part of using cloud repositories. And the comparable to AWS would be Code Pipeline. Now, Code Pipeline, for folks that are not familiar with AWS, is that it really helps build, test, and deploy your code, but it also, again, helps define your release processes as well. Really enables you to rapidly deliver features and updates, essentially. And there's, of course, plugins, for example, for GitHub, and you could integrate your own plugins as well. So with Code Pipeline, again, it's really meant to bring in that repository and make it as easy as possible. Now, when it comes to building and testing code, Google has sort of more of a, I wouldn't really say it's an all-encompassing tool or a total tool, but it pretty much covers just about everything you'd want around a mainline or a pipeline with automation, and we would call that Cloud Build. So Cloud Build is very similar to Code Build. So Code Build is a managed build service, and it provides that scaling that you're going to want, of course, with CI and CD. So Code Build is going to essentially provide automatic scaling, grows on demand, as we already know, and allows you to manage different versions as well. Now, one of the things that's really nice, and this is very similar to Cloud Build, is you could, of course, deploy different versions and compare this as well to see how these copies are actually working out. It's very cost efficient, and again, Google Cloud Build is comparable, if not probably a little bit more efficient in some respects. So we'll talk about that. And then when it comes to automating deployments, again, Cloud Build manages that for you as well. In AWS, that would be called Code Deploy. Now, when it comes to Code Deploy, basically Code Deploy is what? This is going to deliver your working packages, and essentially, as part of that, of course, to your instances, it'll ensure, for example, your parameters are set appropriately. So Code Deploy is going to automate those deployments and allow you to make things easier, to provide a rapid release, essentially. Also, too, it also handles, for example, the complexity of updating your applications. And it's very similar, of course, to Cloud Build, which is also code agnostic as well to a degree. So with that said, that's really the main comparison I want to just give folks quickly. And then when it comes to a unified CI/CD pipeline, we could always tie in Kube Engine and Container Registry. And in AWS, that would, of course, be called CodeStar. So CodeStar is a nice little tool Now, CodeStar is probably one of the newer tools with AWS, but basically CodeStar is a basically development service that you could use to develop, build, deploy your applications on AWS. And again, all these tools I'm talking about with AWS are, of course, dependent on using AWS. But basically, again, just realize that CodeStar is going to make things easier and allow you to, for example, build in like role-based policies, for example. You can manage contributors, etc. Now, generally, you want to use CodeStar if you want to set up, for example, a software development project on AWS, of course. It has all the tools built in for that. With that said, that's sort of about as close as I could get it to GCP and AWS. Now, when it comes to Cloud Build, for example, Cloud Build is essentially going to run your container images in a fast, consistent, and reliable manner. It's going to take essentially your containers, which are going to be Docker-based images, and deploy them in whatever environments that you set up and automate. Now, Container Registry is going to manage these Docker images and look at these images and perform essentially analysis to determine if there's vulnerabilities, decode essentially access control, and ensure that only the folks that are allowed to access the mainline or pipeline or these images will be able to. So I like to call Container Registry sort of like the lockdown for your pipeline. Cloud Repositories, this is again our GitHub. This allows us to securely manage our code. We don't have to leave it essentially on GitHub or anything. It's a private Git, essentially, is what it is. Now, when it comes to continuous integration with Google Cloud, it's really important to realize that we can, of course, use our services in Google Cloud, but we could also use other services if we so choose. So if we want to use, for example, an on-prem solution that we're already using, such as perhaps Jenkins, we could, of course, tie that in. If we're using Puppet, we could, of course, tie that in if we want. If we don't want to use cloud source repositories and just use our current Bitbucket, we can do that as well. So we have a lot of flexibility in how we deploy our services. Now, when it comes to continuous integration, again, we want to think of the fact that on Google Cloud, we are not limited to just what Google offers. So if we don't want to use, for example, Cloud Build, we don't need to. If we want to use, for example, Spinnaker, or we want to tie in other services like Jenkins, absolutely. Now, one quick note. Now, I'm over at the Cloud Console, so I want to just do a quick little discussion here on other tools that we could integrate into Google Cloud. So if we go to Marketplace here, the Cloud Marketplace, again, is very comparable to what you would get on AWS. So if I wanted to, I could go down here, for example, to Kubernetes apps. And you could see that there's a lot of different options. We have everything from monitoring to Couchbase to Elasticsearch to other services like GitLab. We have Jenkins, of course. We have other services like Neo and Nginx. A lot of other services that we could consider using on Google Cloud. Now, we also have development stacks as well we could use. And then if we go back and get that out of the way, we could also go over, for example, to developer tools. And as part of this, we have a different selection here. Some of them are going to be, of course, redundant to what we just saw, but a lot of this is going to be useful. So we go over here and take a look, and there's several pages of options to this. So once again, if we want to, for example, look at Jenkins, we could see that we have different options for Jenkins as well. And there's also CloudBees for our services with Jenkins as well. So that's just one option. But what about if we might want to use Puppet? So again, we don't have any options for Puppet, but again, if we wanted to, we could always tie in additional services if we want to do a little extra work. So again, a lot more services to consider. So let's go ahead and just do one more search and actually get this out of the way. And let's say, for example, we want to go ahead and look for Chef, let's say. Now, Chef is a very popular tool. You go over here to use what's called Chef Automate. If we select that, this tells us what we need to do to get this enabled on Google Cloud. What's nice about a lot of these predefined templates is that they're going to basically include a lot of the integration requirements. So you do need to have, in this case, an existing Chef account to be able to use this. Now, for example, if we wanted to use Jenkins, we could launch Jenkins on basically on a Bitnami platform, which will be on Compute Engine. And if we go over here, you could see when I maximize that, this tells you essentially the configuration that's going to be deployed. It'll deploy all the packages that are required to get this working. So we'll go through a short demo on this in the Cloud Launcher and how to deploy an app. But again, it's very simple to do. And we just select here, we call it a deployment name. We could select the machine type. We have the ability to select the type of disk. And then again, once we're ready, let me go ahead and maximize that. Due to the fact it might be hard to see on the screen, I'm going to go ahead and deploy it. And it'll go ahead and deploy. And what's going to happen is, and we'll talk more about how all this works, is it's going to use Deployment Manager. And then once it's done, we go over to Compute Engine and actually start configuring it. It'll be ready to go essentially, but we'll have to do some work to get that integrated into our continuous integration and development pipelines. So let's go ahead and move on, and we'll go through a demo on this as well throughout the course. So we know we could deploy tools like Chef and Jenkins and other services. And again, there's a lot more to that, but I just wanted to do a quick little overview to let you know that you just don't need to use all GCP services if it just doesn't make sense for you. So with continuous integration, we want to use Cloud Build to securely connect to our on-prem resources and automate our build, test, and deploy processes. Let's go ahead and move on. Okay, well, we talked about continuous integration. Let's talk about continuous delivery, which is the next logical step in creating a DevOps strategy and, of course, a mainline or a pipeline. Now, continuous delivery, we know, is again after continuous integration from a DevOps perspective. So let's just refresh our memory. Generally, continuous integration, we're going to be, of course, taking our source code repository, whether it's on GitHub or cloud source repositories on Google or Bitbucket, and then basically building that source code that we're trying to compile, review, test, integrate, etc., and package up. So again, it's usually more of a manual process. Now, what we want to do in continuous delivery is extend that over to essentially user acceptance testing, for example. And we want to, of course, start automating some of this. For example, in continuous delivery, we want to ensure that the application is essentially continuously deployed on test servers. And essentially, we want to generally release it to production anytime we feel it's ready. So basically, continuous integration is the first step, then we're moving on to continuous delivery. Now, continuous delivery, we're going to automate and build, basically, essentially commit as well. And then again, just also too, as part of continuous delivery, we usually would talk about this in a more advanced class, but basically we're going to typically have some kind of black box or white box testing as well. And then, of course, the benefits of doing all this is to lower our risks, to help release, of course, faster, time to market, provide higher quality, lower our costs as well before we get into, of course, the continuous deployment phase. Now, again, the tools that we're going to be looking at would be, of course, Cloud Build. We're of course, going to have cloud source repositories or some kind of essentially GitHub or Bitbucket. And then Container Registry would be part of that as well if we want to manage our images and of course, maintain better control over our pipelines as well. Now, for example, in the previous module, we deployed Jenkins on a compute engine instance. So Jenkins, for example, we could integrate into Google Cloud pretty easily and provide our CI and CD baseline if we so choose. Now, with that said, if we want to go ahead and, as part of that, of course, provide automated builds from Git, or we want to provide dedicated build servers, we can, of course, do that as well. So we have just so many options when it comes to Google Cloud and also third-party tools as well. So Jenkins, we know, is what? An automation tool, and it's written in Java. It has a fairly extensive plugin capability as well. And, of course, we could use this as part of our CI and our CD pipeline as well. But basically, when we're thinking of Jenkins, it's an open source tool. We're likely using this in a lot of on-prem situations as well. And, from a cost perspective, it's free, it's open source. It's also built on Java, so there's a lot of knowledge out there around that. As far as, for example, with continuous integration, continuous development, generally with Jenkins or any other tool sets that we may be using, there's going to be pros and cons to using an on-prem solution or a cloud solution. So we have some choices, just some thoughts to think about. But what I'd like to do is go back to the demo here and just go through the next step. Now I'm back at Deployment Manager. So what had happened is we had deployed in the previous module Jenkins to essentially Google Cloud. And basically we went to the cloud marketplace and deployed the templates. And we know that when we deploy this, we're deploying a stack of resources. So you can see here the software that's deployed. We have everything from Apache to OpenSSL to Tomcat. Now, if we want to go ahead and connect up, what this provides is this solution provided by Bitnami is going to allow us to instantly get set up and get our plugins ready, for example, and deploy this on Compute Engine. Now, we'll go through some of the facets of this solution. We won't go through everything, of course, but I just want to get people started to start getting ready for more advanced courses on this or more advanced practice, whatever your situation is. So the next thing we want to do is go over here to the site address. Now, Google and Jenkins, as well as actually, I should say Bitnami actually set this up, basically provides us a admin user and a temporary password. So what we want to do is copy this password and go ahead and select this link. And remember, our admin user is user. So we go select the link, and it'll bring us over to this. Because I already logged in, it basically saved my information. So again, it's fairly straightforward. You just log in, cut and paste your password. Now, what we come upon here is we have two different options. We could install our suggested plugins if we select there. And this will basically go ahead and select basically the required dependencies. For example, it'll give us the instance configuration that we'll go to. And then down the bottom of the screen, and I know this is going to be hard to see, so let me see if I could maximize this for folks, because again, my screen's a little bit limited. Okay, there it is. So you can see there, it's deploying Jenkins 2.164.2, so I go save and finish. And so the setup is complete. So what we have to do now is essentially restart Jenkins. So we'll go ahead and restart Jenkins. This may take a minute or two, really depends. So we'll come back when that is done. So our Jenkins is restarting. We're going to go ahead and continue on with the module. And then the next module, we'll go ahead and go back and take a look at it and validate it's good to go. So once again, if we want to go ahead and use Cloud Build, which has, again, a lot of the same capabilities as Jenkins, for example, we could do that. Now, again, a Cloud Build allows us to extend from Google Cloud to on-prem. So there's a lot more to this. We'll be, of course, going through this a little bit more in detail, but we just want to get you started on some of this as well. So these are just some of the tools available. Now, when it comes to continuous delivery, for example, a lot of customers I see use Spinnaker. So if we want to use Spinnaker, we could of course extend out as well and use Spinnaker. Now, Spinnaker, for those not familiar with it, is an open source, basically multi-cloud continuous delivery platform. It's going to do essentially a lot of the same things that other tools will do as well. It's going to provide essentially two features: application management and deployment. Now with management, essentially it's going to allow us to view our resources, to manage those resources. And Spinnaker generally refers to applications as a microservice in a lot of cases. Now it's going to deploy this generally in a cluster approach. We're going to call it like a server group essentially. But basically, that's just one facet of Spinnaker, for example, over here. So basically, we could perform what's called canary tests, whatever you want to do. And basically, it's going to go ahead and load balance. It has a firewall. We could deploy our application as well. Allows us to construct and manage our CD workflows as well. But basically, the main sort of thing to think of Spinnaker is that it's going to create and allow us to manage our pipeline in an efficient manner, and it'll allow us to do this in a multi-cloud hybrid cloud environment. Now there's a lot of terms behind Spinnaker I won't get into at this point, like stages, for example, and also some other terms such as a server group, etc. But just think about this as a way to also create a CD pipeline and manage the application and the images as well, all in one nice, easy to use package. Now, when we consider tools on Google Cloud, we of course have Cloud Build, Cloud Source Repositories, Container Registry, and Compute Engine, for example. Now, for example, with Compute Engine, in the demo, we're using Compute Engine essentially to deploy Jenkins. So Compute Engine not only can extend our services into Google Cloud to other cloud services, but also to our on-prem. So when we deploy Jenkins, we could extend everything outside of Google Cloud. And same thing if we want to use Spinnaker or Chef or other capabilities, like for config management, we might want to use Chef. So these are just some of the components that we can consider. So for example, with Google Kubernetes Engine and Spinnaker, you could create essentially a robust continuous delivery workflow. This helps you ensure that your software is shipped and is effectively efficient and is done as quickly as possible. And as part of that, of course, we're going to have basically our services managed effectively. And of course, we know we could do this several different ways. All right, so let's move on to the next module and start putting this all together. Now, let's talk about continuous deployment. So continuous deployment is, of course, the next progression after continuous delivery. So essentially, what is the difference between continuous delivery and deployment? So we know that continuous delivery is essentially where you're going to build the software and then release it to production. Now, continuous delivery is generally achieved by integrating essentially all your products, your solutions, etc., with your dev teams, running those automated tests, etc. Continuous deployment essentially is going to be a little bit more, one more step from more or less a manual process to an automatic process. So continuous deployment means that every change that you make goes through a pipeline, and if it passes the test, it will automatically get deployed into production. And because of this, the goal is to essentially, of course, automate, but also provide higher quality software. Now, as part of this, generally too, we want to think with continuous deployment, there's not really going to be any kind of manual processes like approvals or anything. It's going to be essentially released automatically. Now, again, this is a progression that's going to take some time for a lot of organizations. It's not a one-day process. It's not a very simple process for a lot of customers. But the thing is to start bringing it all together, of course. Now, continuous deployment, from a definition perspective, is an extension of continuous integration and, of course, continuous delivery. Now, the goal is, of course, to lower the risks, reduce your lead time, provide quicker feedback. It's really about automating your processes. And, of course, all of these Google tools will be part of that solution. Now, let's talk about continuous deployment in the sense that we have, for example, here with GCP Cloud Source Repositories, we have Cloud Build being used, we have Spinnaker, and we also have Kube Engine as well as part of this with some load balancing. So this is an example where we could use some tools to help automate some of this delivery and deployment processes. Now, when it comes to again, bringing it all together, we want to have a pipeline that is going to, of course, code, build, integrate, release, and deploy. And between release and deploy, this is, again, where we're going to automate everything. Generally, from the delivery, continuous integration, and delivery, it's usually more of a manual process. So when we think of, for example, delivery, we're going to want to, of course, test. We're going to want to stage. We're going to want to have, for example, production copies. So continuous integration, we're going to want to try to, of course, as part of this, automate our releases and try to reduce, for example, the manual deployments to production. With continuous integration as well, with continuous delivery, we of course are going to do what? We're going to want to automate these deployments. So that's generally the main difference between delivery and deployment. But again, there's a lot more to the story here when we consider every organization, what they can and can't automate, tool sets that are available. When you're using specific tools for your pipeline, whether it's Jenkins or Cloud Build, there's going to, of course, be factors to consider. Basically, the software that's being delivered, the efficiency of your environment, and any kind of processes involved that need to be automated. So let's go ahead and continue on, and we'll talk more about each of the services now. So with continuous deployment, we want to be able to modify our app code, trigger the pipeline to automatically rebuild, retest, redeploy the new version. Basically, it's about automating everything that you can. In this module here, let's talk about managing your source code, managing specifically your source code with Google Cloud Platform. Now, Google provides you several options. The most common would be to use GitHub or perhaps Bitbucket, but also Google does of course have options such as cloud source repository. Now, when it comes to managing your source code, you're going to likely have multiple versions, multiple users, developers. You'll likely want to keep track of what are the production versions, which are the ones that are not being rolled out to QA or production. Have some kind of version control. Generally, you're going to, of course, want to have some kind of CVS system as well. That's up to you to decide what might work with your deployment. Now, some customers choose to also tie in their version control software. Some of the common ones might be BitKeeper, ClearCase, CVS, whatever that is. You may want to determine what's going to work between, for example, your on-prem and Google Cloud. Whatever that is, there's a lot of options that you could go ahead and look at. Have a repository model set up. Once again, the easiest way to get started is, of course, GitHub. You could always go into GitHub and fork it over basically to source repositories to keep it more local, to have more control. And if you do that as well, it enables you to really create essentially a true in the cloud, basically pipeline to help you manage your source code from start to finish. With that said, definitely look at issues as well, such as concurrency. One of the challenges that I've seen companies run into is really trying to make sure that when they roll out their code, they have their repository set up, that the clients that are uploading or managing the code, basically are able to update, or actually the term I should use is propagate to basically the system and to other users. And Google Cloud handles this, wonderfully as well. But with that said, look at whatever solution makes sense. It could be BitKeeper, it could be ClearCase, Codeville, CVS, CVSNT, whatever is going to make sense in your organizations. With that said, the limitations that Google puts on you is pretty next to nothing or minimal. And whatever you could tie into GitHub or Bitbucket is pretty much your limitation in a lot of cases. With that said, let's move on to the next module. Let's talk about Google App Engine. Now, App Engine is one of the longest running cloud services in Google Cloud. So, very popular service, widely used by an array of developers and organizations. Now, with Google App Engine, it is a platform as a service. So, what we want to think of from this perspective is that it's a managed service because of the fact that Google is going to manage the virtual machines in the background and load balance and scale. Now, you also have the power as well to specify how some of this works in the back end. So they give you some flexibility in how you want to deploy your services and how the management of those services is handled. Now, it is hosted on Google's infrastructure and networks. Essentially, we know that Google's networking is solid as a rock. Their data centers as well, well-provisioned, low-latency network. Supports source code, of course, that you generally would want to deploy applications on. There's two environments, standard or flexible. And there's SDK kits where you could download and of course, develop locally on your workstation, laptop, etc. Now, App Engine is a regional service, and I'll talk more about that in the next slide. But basically, you could see the regions here that currently at the time of writing the course, it is available in. When we deploy a regional service, this sort of makes us think about where our user base is and who's going to be accessing our resources. Now, when we deploy App Engine, because it's a regional service, if it's located in basically the US or Finland or wherever you're going to deploy it, you can't move it. In other words, when you deploy it in a region, it stays there. You can't just move it or do anything with it. So that brings up the concern over what we're going to do from a scalability perspective or an access perspective. What we want to do, of course, is distribute our users among different App Engine instances in most cases. Because again, it's a development platform. If you have developers in India, it makes sense to develop locally and as locally as you can. So what you want to do is, of course, deploy App Engine in India if you can. And if you have your users, your majority of your users in the US, same thing goes with that. So you have to consider that from that perspective. Now, there's free and paid resources available, supports the Spring framework as well. You also have access to Memcache, again, provides some performance boosts with your querying, for example. Support and SLA is included as well. Now, there's two environments, and again, we know it's flexible and standard. Now, I think that the main thing to point out here is that essentially the services are generally the same between the flexible and standard. The main differences are the fact that if you need, for example, a specific runtime environment that is not supported on standard, you want to go with flexible. Now, standard environment deploys a sandbox, whereas flexible environment deploys containers. And now that brings up another question is, well, if it deploys containers, should we use Kubernetes engine or Kube engine for short? Really good question. So we're going to address this coming up in one of the modules shortly. But basically, one of the challenges with making a decision between environments is really around what you need. And a lot of the decision is just going to come into play from the amount you're going to use it, the flexibility you need. But again, a lot of it does come down to do you need containers or do you not? Or if you need to deploy a custom runtime environment, again, standard is not the right choice. Now, the flexible environment does start up a little bit slower. Standard environment is a little quicker. There are, of course, some restrictions listed there where flexible supports different processes and debugging, etc. But again, from a service perspective, you're still deploying compute engine in the background, and you still can use services from data store to cloud storage and whatever else that you may be thinking of. Now, there are, of course, some limitations versus what's free and what is not. So, for example, with App Engine, and again, you want to check this based on the time of viewing the course and using and setting up App Engine, because again, this stuff can change pretty quickly. But basically, the maximum number of services and versions you can deploy is going to depend on the pricing structure. So if you want to deploy, for example, 5 apps, that would be considered free. But if you're going to deploy more than that, then there's a charge for doing that. Also, too, when it comes to instances for scaling, there's some limitations. And one note, too, is I think if you deploy it in Europe versus the US, there's some limitation differences as well from what I remember. So it's like 200 versus 25 paid applications for support. But again, we can certainly use App Engine for versioning. We could use it for A/B testing. It's so powerful. It is really a tool that developers really, if they're using Google Cloud, really should consider using. Now, standard, and this is again at the time of writing, so I would encourage you to double check the App Engine web pages to validate what's supported when you're viewing this. But basically, at the time of writing, here was the runtime environments supported by standard. So if you want to use Python 2.7 or 3.7, you're good. But if you want to use, for example, a newer version of Python or an older version, you need to consider going to flexible environment. Same thing with Java, Node.js, PHP, and Go. With that said, if your application can be developed on these runtime environments that are listed, you're good to use standard if there's no need for containers or advanced features. On the other hand, if you want to use, for example, a different version of Go that's supported in standard, you need to go to flexible. So I hope that's clear. Again, check the website to validate what is supported at the time of viewing. App Engine also has a security tool. There's a demo on this where we'll go ahead and scan a WordPress app for vulnerabilities. But basically, it's built in, and it's called Security Scanner. It's a really nice tool that enables developers to look for vulnerabilities that are known. So, for example, any kind of CSS script issues, any kind of port issues, any kind of other known vulnerabilities that could be a concern to the developers. And again, the goal with running Security Scanner is to be proactive and define these known vulnerabilities before deploying the application. So if you have any scripting issues that are obvious, any kind of open passwords or anything that really shouldn't be there, it'll generally look for that and pick it up. Now, as far as App Engine VM highlights, couple things to point out. Google, because it's a managed service, is going to handle the health checks. They're going to scale. One of the things, too, is that they'll take care of the upgrades and basically maintenance on this as well. So developers don't have to worry about managing virtual machines if they don't want to. There is root access as well provided. You get SSH. Now, Google generally will restart instances on a weekly basis. And at that time, they'll upload any changes or updates. With App Engine, we know that it's a long time that it's been deployed. It's been running historically since approximately, I believe, 2008, and so basically I think the initial release was 2008, and then it actually went into production basically in 2009. So it's been running approximately 10 years, so a long time. And actually App Engine was actually App Engine before Google Cloud was even incubated. From a historical perspective, this is pretty much Google's longest running public cloud service. Let's go ahead and move on. We have a lot more to talk about. In this demo, let's go through App Engine. Now, App Engine is a platform as a service. This service you could deploy in two different service approaches. You could deploy standard or the flexible environment. Let's go ahead and deploy an App Engine instance. Before we get started, what I'd like to do is just validate, do we have, for example, an App Engine dashboard window? So let's go ahead and go to Customize, and we'll go ahead and turn that on just to validate. And we want to start up App Engine. Let's go over here to Compute, select App Engine. Now, what we want to do, we want to go ahead and deploy an App Engine instance. So let's go select Create Application. Now, there's also a tutorial. I'll walk through that as well. And you could also deploy this as well with the command line. For this exercise, let's just go ahead and go create. And I want to show you visually the zones and regions and how this works first. Now, when we select a zone or region, if we select like US East 1, you could see that it'll pop up Charleston, South Carolina. Now, if I select South America East, it'll bring up Brazil. And again, India, for example, Asia South 1. With that said, because App Engine is a regional service, we have to be careful with how we deploy this. We can't just move our instance from Charleston or Iowa or Northern Virginia to the West Coast or South America. So we want to regionalize our application planning. We want to understand our user base, our developers, or our user base, whatever makes sense in your organization. So we want to go here and just create an app. When we create an app, it's going to prompt us to select the language that this is going to be in. I'm going to go ahead and select Python for this exercise. And then we have the choice to deploy flexible or standard. Let's just deploy standard, go next. Now, it brings up the resources area here, documentation and GitHub. And then if we haven't downloaded the Cloud SDK, we'd want to do that. Now, you can see up here that it is deploying the app, and it says that this app has been successfully created. And now I'm going back to the dashboard. I just want to see if App Engine has caught up to the polling, and looks like it started. Okay, now let's go over here to services. You can see that we have one service listed here. That's our default service. You can see that we have up, and it may be a little bit challenging to see. Let me see if I can move this just a little bit. Okay. Anyways, you can see that it says Hello World, and it gives you the project dash the appspot.com URL. So basically it deploys this Hello World app that was in Python and deploys the Django and a couple other services as well with it. But this is a good way to get started to play around with App Engine, because this is a very powerful service. It's been around the longest of any of the major cloud services. So when it comes to development and deployment, it's really hard to beat Google with a lot of these services. Okay, let's go to versions now. Now, versions would be if I basically split the traffic between A/B, for example, like if I want to do A/B testing or even possibly canary testing. Go over here to instances. You can see that over here. And let me minimize my screen because I know that you may not see it as well. Let me bring it over a little bit. Okay, so that should be right there. You can see that it started kicking off. It tells me the number of requests. And if I go back here, do a reload, that once it reloads, you'll see that it will catch up eventually. Now the latency on this, again, may be, let me see, client, and I've seen it take, there it is, okay. So you can see that it does update, and it says January 30th, 9:16 p.m. So with that said, not too much activity. It's just a Hello World app. I'd recommend, if you haven't used App Engine, to play around with this. I have another module where we're going to go through security scans, for example, and then also we'll go through some of the settings. But with that said, go back to dashboard. You could see that it kicked off. What's cool too is you could see the billing status, so you have an idea of what this is going to cost you. So with this setup, I'm looking at about 0.055 cents per hour to run this application. And then you can see the current workload, requests per minute, etc. And we just move that out of the way, see this a little better. Let's go back to App Engine, actually to the main dashboard. Okay, so you can see that the summary page is caught up finally, and you can see that the server response count is being updated. With that said, it's very easy to deploy one of the demo apps in App Engine. I recommend you take a few minutes to do it. Let's move on. In this module here, let's go through a short walkthrough of security scans with App Engine. This is actually a really cool tool that you as a developer can use to help alleviate security concerns and vulnerabilities, etc., before you deploy any application. And the tool in App Engine is security scans. So let's go over to security scans. Now, before we are able to use this, as you would expect, any service in Google, you have to enable the API before you can use a service. So let's do that. Enable API. Okay, so it's been enabled, and we want to go create a scan. What we want to point to, because this is basically a Hello World application, generally we want to, you can see there it populates the URL, and it picks up, if you had multiple App Engine instances running, you can select what you need. But in this case here, we go down to more, and we could also use Chrome as well as Safari, BlackBerry for those that use BlackBerry. And then we could also adjust the speed as well. Now, authentication, we could use our Google account, etc. We could also look for what's called a URL pattern as well. So let's go ahead and create. And it will go ahead and run the scan when I kick it off. I go run scan. What this is going to do is it's going to go through the App Engine application through the URLs, basically starting at the root URL and work its way through. It'll let you know how long it took, and it'll pop up any vulnerabilities that it may find. Now, because this is a demo app, there's really nothing going on, and it's just using pre-tested code from Google. It probably won't find anything, but I would encourage you, when you first start deploying apps on App Engine, to definitely go ahead and play around with this and see what it comes up with. So we'll go back to this when it gets done. This may very well take 10 minutes or so. I've seen it take longer. I've seen live production apps essentially take 20, 30 minutes. This was actually pretty quick. Actually, it got done before I even went to the pause. So it didn't find any vulnerabilities. And then go over here, URLs tested. You can see that it started with the home directory, did the get method essentially, and then details. Basically, the user agent was Chrome on Linux. With that said, this is security scanner, and you go over here to delete the scan if you so choose. With that said, we'll go ahead and move on. Now let's talk about why you may want to choose App Engine, or you may want to choose Kubernetes Engine to deploy your application on. And that's a really good question and a common question I get. So I wanted to address that because it is an extremely interesting question, in the sense that a lot of the basically features and functions are the same in some respects. So for example, when we consider using Kubernetes engine or Kube engine, we could also deploy containers as well and App Engine Flex as well. Now, App Engine Standard would be out if we wanted to use containers. So that's sort of the starting point. Is it's easy to rule out App Engine Standard, but how do we rule out App Engine Flexible environment versus Kubernetes engine? And it really comes down to a couple factors. So with this said, App Engine Flexible is actually focused on application development. So for example, if you have an application you want to deploy and have it managed by Google on Google Cloud, then great. On the other hand, Kubernetes and Kubernetes engine, remember that you could deploy Kubernetes on-prem as well. So if you're using on-prem Kubernetes, then it would make sense to keep on doing that, or maybe extend it out to Google Cloud, depending on what you're trying to do. But Kubernetes is actually more flexible in what you can do. Another benefit as well with Kubernetes is around the portability and the independence of essentially your cloud platform. So you could move those containers around wherever you want. Now, App Engine Flexible, once you deploy an App Engine Flexible, you're pretty much there because it's being managed by App Engine Flex. Also, too, App Engine Flexible has some limitations as well into basically how many applications you could deploy. Also, too, for example, one of the things is, how do you migrate out of App Engine? Again, there's some things to think about there. There's also performance challenges as well, the way it scales. But one of the things too is if you do use App Engine, it's actually automated for you in the sense that Google's handling everything in the background. It's a managed service. With Kubernetes engine, generally you need to spend more time managing it, and therefore it requires essentially more administration. But with that said, it is a container service either way. It's just a question of what you need. Now, with Flux as well, basically you're deploying, for example, with App Engine, you're going to have a number of containers of one type. With Kubernetes engine, another thing too, they deploy more in a pod approach, for example. So there's, again, a lot more to consider. It's not like, a 1 hour discussion at a deep level, but there's some other things to think about, and I'll just list a few for you to think about and consider. One of the first things to consider is to understand how the containers are used. With Kubernetes engine, it's more about the containers. With App Engine, the containers are more or less in the background to the developers, so they're not managing containers. With Kubernetes engine, it's all about the containers and keeping track and managing them. So basically, the user of App Engine doesn't really, per se, get concerned about what's really going on in the background. Basically, App Engine was designed to be a tool to manage all these services and allow the developers not to have to deal with a lot of this. Now, when it comes to Flex, generally, the Flex environment with App Engine, it can definitely, in the right use case, probably provide better throughput. Because again, it's directly on Google's infrastructure and it's all managed by Google. Now, one of the things to also think about is that App Engine is going to scale automatically. And because of that, again, it's hands-off, whereas GKE, the pods can, of course, scale, but there's a little bit more work to have it do what you need. So, for example, scaling up the number of nodes may take a little bit more work to get it correctly the way you want it. So, for example, how do you address a workload that spikes versus a gradual increase? Now, one of the things to point out as far as similarities is that App Engine and GKE do share the same resources. So for example, you'd utilize the load balancer, manage infrastructure groups as well, instance groups. But again, from a compute engine perspective, again, it's still going to use those resources as well. Now, some of the templates may be a little different as well. For example, how do you scale, for example, adjusting your vCPU, your RAM resources, etc. Also, too, last thing to talk about before we move on is pricing. Now, it is pretty clear that if you want to manage GKE yourself, the resources that you're using would be somewhat cheaper in a lot of cases than if you used App Engine. So you have to look at, for example, the virtual machines that you're using. So for example, if you wanted to use preemptible VMs, it would definitely lower your cost with GKE. With App Engine, that's not really that's not really going to be the case, because App Engine won't be using preemptible VMs generally. So if you want to deploy containers for a short test, for those not familiar with preemptible VMs, generally it's going to be a VM that's going to be similar to a spot instance with AWS. That's a loosely comparable comparison, to be honest. But basically, you're going to get a price at about an 80% discount as compared to a standard VM. So cost perspective, you could save a lot more money with GKE depending on what you're doing. All right, so there definitely would be a lot more to talk about with App Engine and Qwiklabs, but from a development perspective, I want to give you some ideas to think about and start looking into, as far as what is right for your environment. Let's go ahead and wrap up the module here. So we want to just make sure that we do understand from a review perspective that App Engine Flex is certainly more automated than GKE. And if you want to use GKE, you have better flexibility and perhaps cost savings, but you'll be doing more work as well. All right, let's go ahead and move on. Well, let's go ahead and discuss what a container is briefly, and then talk about the pros and cons, and then compare it as well to a VM. Now, assuming that you're taking this class, you probably have a good grasp of what a container is, why they're important. But for folks that may not be too familiar with them, I just want to touch on basically what they are, why they were important, etc. So let's go ahead and get started. Containers are basically going to be virtualization at the OS layer. Now, when we compare this to like a virtual machine, we want to think about some differences as well. Now, a virtual machine is generally going to be running the VM in its own operating system, whereas typically a container will share the host OS. Also, too, generally the virtual machine is hardware level virtualization, whereas the container is OS virtualization. And of course, we could talk, significantly longer about different, reasons to use containers, why not to use them. But basically, again, containers are going to be something that we're going to absolutely use in the development world. And when we're deploying applications, CI pipelines, containers is really where it's all at. When it comes to what a container is from a definition perspective, here's a definition here. I won't sit here and read it to you, but generally think of a container as a way to package up your code and deploy it. And for example, Docker container images are very common. You're going to run into Docker most of the time. There's other containers out there, for example, providers, I should say, such as Linux containers, LXC, LXD, CG Manager. There's also Windows Server containers. But with that said, basically what we want to think about from a DevOps perspective is that they're lightweight, secure, and efficient. And you could see that you have your infrastructure, your OS, your Docker containers, and your apps that are running on a container on Docker, for example. And then as far as container types, these are, again, just some of the ones you're going to see on the market. Solaris Zones, BSD, for example, as well. And then as far as deployment engines, basically how do we orchestrate our containers? Docker Swarm is very common. Kubernetes engine with Google is another one. Amazon ECS, if you use Amazon. Then Azure has Azure Container Service. There's Marathon as well. Now, when it comes to container disadvantages, generally they're going to be fairly small. And, one of the things to consider is because of their size, they're going to deploy quicker. So, when it comes to advantages, the size does matter. As far as resource usage, deployment scenarios, ease of isolation, etc., just some of the benefits. Now, disadvantages could be security concerns, could be operating system flexibility, and then also networking integration. Once again, there's certainly a lot more to consider, and some of the disadvantages and advantages, for that matter, could vary based on the type of container you're using, Docker versus like Linux containers. With that said, we again can realize that containers have advantages and disadvantages. So when it comes to advantages of containers, we know, for example, they're lightweight, performance is going to be better, it's going to share the host OS, the startup time's quicker as well, uses less resources, so for example, less memory. But again, as part of some of the benefits is going to be disadvantages, and we know what they are already. Could be less secure as well. Let's go ahead and continue on here and wrap up the module. So we know that containers have amazing benefits when you pair your containers with a solid use case. Again, containers have pros and cons. It's really about the type of containers you deploy, how you deploy those containers, and how that correlates to your use case. Let's move on. Let's talk about Kubernetes engine, known as Kube engine as well. Now, if you're going to be deploying containers on Google Cloud, you're likely going to be familiar with this. So when it comes to deploying your containers, we want to understand that Kubernetes engine is essentially going to be a deployment service that you're going to use on Google Cloud. But basically, we want to think of Kubernetes generally, and again, you may be using Kubernetes in your environment already, and again, on-prem, but basically we know that it's a portable, open source format that's essentially a platform for maintaining and managing your workloads that are containers. It's going to help you facilitate and basically ensure proper configuration and automation of your container services. So for example, one of the things to keep in mind is when it comes to Kube engine, for short, basically this came as a result of Google's open source project back in 2004. They decided to have essentially a service in Google Cloud around Kubernetes engine. So essentially, we know that there's a lot of great features as well, but basically, again, we want to think of it as a container platform, a microservices platform, and essentially it's a portable platform as well. So if we want to move from on-prem to the cloud or cloud on-prem, this is really great stuff. And again, this is more of a platform as a service as well as infrastructure as well. It's really a hybrid solution. With App Engine, it's really a true platform as a service. This is more or less hybrid. So what we're going to cover in this module, we want to cover what it is, why you want to use it. We'll talk about if it's managed or unmanaged service. We'll talk about G-Cloud and some of the commands that we may want to dive into as well. Now, with Kubernetes engine, it is a fully managed cluster management system. It's going to orchestrate your Docker containers. We also know that it's based on Kubernetes, and Kubernetes was, of course, an open source project that basically Google supported and maintained, and basically ensured that this was, basically out in the open source community. And what it's going to do is it's going to deploy these, basically what's called a cluster on Compute Engine. And we'll talk about some of the terms as well in some of the demos that we do. Has a robust API ecosystem as well. So we know that it's a managed environment. It's going to deploy efficient Docker containers. Right now, it only supports the use of Docker containers. So if you're using Linux or any other format, it's not supported at the time of writing. And again, the goal is to run containers that run workloads. Now, when we deploy a workload on GKE, one of the things we have to do is package that workload into a container. And again, to do that is fairly straightforward. And we have a demo that will run through setting up a cluster and everything. Now, where does this all fit in? Again, with Kubernetes engine, there's certainly complementary services as well. So we want to think of Kubernetes engine as just one part of your development and operations services, your DevOps pipelines, for example. So for example, we're probably going to want to use this with Container Builder, Google Cloud Build, for example. We probably want to use this with Container Registry as well. Again, we have some options there that we could look at. For example, when we deploy a pipeline, we can integrate or extend it to other tools. Very common to see Kubernetes and Kubernetes engine as well deployed to other services such as Spinnaker, Jenkins, etc. And we talked about Jenkins earlier in the, I believe, the CI and CD section of the course. Now, some other basically rationale over why we may want to use Kubernetes engine is because of portability. If we're already using Kubernetes in our in-house platform, for example, great, makes life easier. We could just port over our containers. Another thing, too, we could use this across cloud providers as well. We could also federate between our on-prem and Google Cloud, for example. It is an open and modular format, supports rolling updates. Also, too, you could upgrade your applications with zero downtime. It auto scales. And again, it'll adapt to workload changes as well. And again, fairly straightforward. It's really a container-centric management environment. It's really about orchestrating everything as efficiently as possible. Now, when we also consider, for example, GKE, we want to enable the users, the developers, to manage applications and not machines. To accomplish this, you really need to understand the abstractions for applications. For example, any data access that's mounted to a pod is called a volume. And then anything else, for example, that's available to all containers is also in the pod as well. Now, containers, again, that are part of the same pod are going to be scheduled together. And this is where Kubernetes engine really comes into play, because you're going to deploy a cluster, for example. Also note, if you want to deploy your containers using persistent disks, this can also provide some additional benefits as well. Now, there's some other terms. Again, I'm going to probably expect most of you to already have an idea if you're a developer. But if you're not familiar with what a pool is or instance groups, definitely take some time to get to know that. As far as some of the other benefits to think about, for example, you want to look at your quotas as one of the restrictions in your region. So what I'd like to do now is go over to the console, walk you through some of the features and functions, and then we do have, I believe, another demo or two coming up as well on Kubernetes Engine as well. Now I'm in the console, so what I want to do is go down to Compute. When I go down to Compute, you can see that it brings up Kubernetes Engine. And when I select that, it's basically saying nothing's been deployed. Now that's true in this specific project. So when we deploy our clusters or workloads, basically it's going to deploy our cluster in the background on top of Compute Engine. Now I already deployed a cluster, so what I want to do is go to the correct project and go see what's going on. So give me a second here. Production might be it. No, it's one of these projects I deployed it in. And bingo, there it is. So it's in another project. So one of the things we want to consider is when we deploy Kubernetes Engine, and I have a demo coming up on how to do this, so I won't go through and walk through it, but I just want to point out some things to start thinking about when you consider deploying Kubernetes Engine. So it's going to deploy a cluster, essentially. Now, what's a cluster? A cluster is going to be, in the world of Google Cloud and Kubernetes Engine, GKE, for example, basically it's going to be 3 or more nodes. So when we click on this, we will, of course, see 3 nodes in the pool. Now, we could also validate this by just simply going back here and looking at the cluster size. Now, we could also connect to the cluster, and it gives us the gcloud command, and we could run this. So if I copy this and run this in Cloud Shell, this will bring up Cloud Shell. Now, for those folks not familiar with Cloud Shell, this is essentially a very small virtual machine instance that is deployed essentially in Google Cloud to help you connect. Because you're already logged into the browser, the console, it brings up this instance, basically in your memory, and allows you to not have to log in with, like, for example, the SDK kit up here. So if I go over here, I could also do the same thing if I wanted to run this locally. And if I go over to the Google Cloud SDK and bring up the shell, that's doing the same thing. Now, if I didn't want to connect with the VPN, or it was just, a little bit more to connect, or I didn't want to go over the network or whatever, then this is perfectly fine as well. So basically when you connect up, it already copies in that command. And then what I could do here is just go ahead and hit enter. And this will go ahead and generate essentially the endpoint and other information about the cluster. So this is just a starting point. Now, again, if I wanted to run some other commands, we'll go ahead and cover some of those here in a second. So I'll hold off. We'll come back to this after and then talk more about this. And now I'm back. So let's go ahead and talk about where Kubernetes Engine fits in. Now, basically, if we look here, we can see that Compute Engine is infrastructure as a service, and an App Engine is platform as a service. Kubernetes Engine is sort of in the middle in the sense that it's partially managed, but you still need to do your work to maintain your containers, your clusters. But everything, again, can scale up or scale down. You have some more flexibility. But the goal is to understand that it is a partially managed service. And with that said, that's where it fits in. Now, when it comes to Kubernetes Engine, again, here's some commands you may want to look at. For example, if you want to go ahead and view your cluster config, view the deployment or pods, it'll go ahead and list that, kubectl config view. And then if we want to go ahead and create a cluster, we can go ahead and type gcloud container clusters create, and then the name. We want to scale our cluster we just simply go ahead and resize it to 10 or 8 or whatever is supported at the time. So let's go back to the console. Now if I go here, I could go ahead and type kubectl config view. And when I hit that, that's going to go ahead and bring up my config for Kubernetes engine. Now again, there's of course a lot more commands with kube as well. I could also use some gcloud commands to initialize the cluster, etc. Now if I want to, for example, edit my cluster, I could do that as well. But let's go, before we close out, I want to go ahead and go over to Compute Engine and show you how this all works in the background. So I go over here to Compute Engine, and if you could see here, and I will go ahead and minimize this so you could see it a little bit. It's hard to see. Okay, that might be a little better. So you can see that I have a cluster called GKE Standard Cluster, and there's 3 instances. And if we go back over to Kube, you can see that the cluster size is 3, and that makes total sense. That's exactly what we should see. And again, we have a demo I have coming up on creating a cluster, so I'll hold off on going through all this. But if I want to go back, I could look at any workloads that are deployed. Because there's nothing deployed yet, again, I have to go ahead and manually deploy something. And when I select that, I could select the container image or create a new container if I want as well. And I could go ahead and select the source, select the repository if I had that set up. I could go to GitHub. Again, I need to have my API set up to do that. But again, there's a lot more to this. If I want to use an existing container, I could go ahead and select, for example, one of the images here. And again, you could see, again, if I want to select that, I could go continue. And that's basically a container that's running on App Engine Flexible. And then I go over here and go ahead and take that image, and then you set up my variables and continue. So again, this is just one thing that we could just do in Kube. Now, if I go back to services, another thing to point out is that it could also, for example, load balance, and we could tell it, what to do, how to do it if we want. If I go to System Objects, you'll see that it pulls up the objects. And if I go and I select one of these, for example, I could either delete or edit these if I want as well. And again, there's no applications deployed yet. It's just more of a show and tell at this point. And then I could also set up what's called persistent volumes. And persistent volumes will, of course, allow this to be available in case there's an outage or between reboots. And then if I go back to Compute Engine, I can also go over and check out Compute Engine. You can see that I have my 3 nodes there. And if I select on one of these nodes, this basically shows us, for example, that we have logging enabled. We have our instance template here. And again, I could click on that and it'll tell me more about it. Then if I go back here, I could connect to the Compute Engine instance if I want. I go ahead and go to the gcloud command. I could cut and paste that if I want. And again, when I do that, I just go ahead and hit enter. I run this in Cloud Shell to connect to my cluster node. And you can see that down the bottom. It'll go ahead and let me connect. I just hit enter. It automatically populates the command. And then I have to basically enter a key. So I have to enter a passphrase. And again, I would have to set that up or remember what I had said. And there it is. So you can see, for example, there I'm in the node. It gives me some information, tells me the version that it's running, which is GKE.6. For example, for the extension, it provides additional links. And then I can get on here and start using my GKE commands as well. So a lot of flexibility here to actually talk about Kubernetes and Kubernetes Engine is literally an 8-hour class, so much to cover. Let's go ahead and move on. In this demo here, what we'd like to do is deploy a cluster for Kube Engine. Now let's go ahead, go over to the console, and what we want to do is scroll down to Kubernetes Engine. And we'll go ahead and select the main menu. Now, over in the dashboard, what we want to do is just validate what we have. We have no clusters at this time. Now, before we deploy a cluster, let's go over to Compute Engine. When we go to Compute Engine, you'll see that there's no instances deployed there as well. Did this intentionally to show you what you should see before and then after you deploy a Kube Engine cluster. So let's go back and select a Kube cluster here. I'm going to go ahead and select Create Cluster. Now, you could see that there is, again, a lot of what are called busyness as far as options to check. Now, let's just leave it as a standard cluster. Now, when we select a standard cluster, this is going to allow us to set up as quickly and efficiently a pool of nodes that are going to deploy our Kubernetes service for us to utilize without having to basically work the back end and manage the nodes. And that's the benefit of this service. Now I'll go ahead and dismiss that. That's fairly straightforward. Now what we want to do is make sure that we name the cluster something obvious to us. Again, in this exercise, I'll just make it obvious. I'm going to call this, for example, Kube Cluster number 1. Again, whatever makes sense to you and your organization, that's for you to decide. Now, as far as location type, we want to select either a zonal or regional deployment. If you have any questions on that, feel free to take a deeper look into that. But basically, if you select zonal, then that deployment is going to be mitigated only to that zone. Now, if we want to have a regional instance, then of course we need to select that for our availability purposes. Now, when we select regional, we'll see some different updates, but with that said, we're going to go ahead and just leave it as a zonal approach. I'm going to go ahead and select US East 1B, for example. Geographically, that's probably one of the closer regions from where I'm at. And one of the things to pay attention to is I could select the version that I want to use for my master. The default is fine in most cases. Once again, you may be running specific versions or you need to have interoperability or some use case to select another version. That again, do your research and make sure that it's going to work. We could change the number of nodes, but now by default is 3. You don't want to go below that, of course, because again, if you lose one, then you don't have any basically availability in case something else happened. So leave it at 3. You could scale up to whatever you need that is supported at the time. Now, for example, as a best practice, if you're deploying, for example, 10 nodes, that's great. You try not to deploy, just one quick note as far as nodes, and if you need to change them, it's very easy to change these, so you don't have to be too concerned. If for some reason down the road, you either need to add more nodes or less nodes. It's basically an on-the-fly change you can make. In this case here, I'm going to leave it at 3 because, again, I don't need to deploy too much. I'm going to go ahead and customize my deployment, and I don't need as much memory. And again, if you could see, this tells you what you'll be billed for. I could also select GPUs if I needed. Now, I could also select the CPU platform if I so choose. Once again, in this case, for demo purposes, is nothing to be too worried about. You could also select other areas such as the maintenance window. You could also deploy new nodes. So for example, if there's an availability issue, I could have this deploy, let's say because there's an issue in US East 1B, I could then also select the option to deploy it and see if I so choose. So I do get some kind of protection, but again, it's zonal, it's not regional. Maintenance window could be selected. There's a lot of networking options that you can look at. Policies. Now, one thing to point out too on this is down here, by default, it's going to enable Stackdriver logging and monitoring. You really want to leave that on, because if you don't, then what you need to do is actually set up Stackdriver logging and monitoring down the road if you need it. Once again, if you don't need it, then leave it off. I'll leave that up to you to figure out, but in general, most organizations do want to monitor their services. With that said, we could, again, go over here and select some options, but in this case, we'll go ahead and leave it as is. Now, I'm going to go ahead and expand my interface because I can't see what I'm at. I'm going to go ahead and create this cluster. And again, for resolution purposes, I'm going to put it back to the size. And you can see now it is deploying a cluster. We'll go back and check on this. This can take about a minute or two. We'll come back when it's available, and I'll walk you through some more features and functions. Okay, so now it looked like the cluster completed. You can see our Qubate cluster 1. Location is US East-B. Size of the cluster is 3. We have 3 vCPUs and 7.5 gigs of memory. Now we could connect to it as well. If we select here, now I have 2 options. I could run this in the workload dashboard or in the Cloud Shell. I could also, of course, go over to the SDK and access that as well. So this will go ahead and provision Cloud Shell. And when I hit that, it'll go ahead and list basically any kind of configuration variable. So it's go ahead, fetching that information, and it is displaying that there. Now, just one quick note, there isn't anything running. We didn't do anything, so we're not going to see too much, and that's okay. So let's go over here and select the cluster this way. Now, one thing to point out is you could see the details. It tells you what's enabled. We go down here to the node pool. You could see that there's 3 nodes. The version of the GKE is listed there. And again, if I want to go and validate this, I could go over to Compute Engine. And you can see that I have 3 nodes that are running on Compute Engine. And it says GKE Cluster, Qubate Cluster 1. And that is essentially how you deploy a Kubernetes engine cluster. Now, there's a lot more options. We could certainly go into each of these and look at the configuration. We could configure it for Stackdriver if we didn't, or change it. We could set up our tags. We scroll down here, and this tells us actually more information about our policies and services that are enabled. Once again, I go to SSH. This will transfer the keys to the virtual machine. And now I am connected. So I have the ability to go ahead and play around and look around on my node and see what is running and how it's configured. With that said, that's really about all I wanted to cover in this demo to give you an idea of how the cluster works. With that said, it's fairly straightforward. I encourage you to go to Kubernetes and play around after you deploy a cluster. You definitely want to take a a workload look as well. If you don't have a workload to deploy, go ahead and deploy one. There's also here the ability to look at workloads that are system-based. But basically here, when I go to the cluster, I have the ability to edit it, to delete it, to deploy, or connect as well. Then services, if I want to set up load balancing, for example, I can do that. If I want to federate, for example, I can also take care of that. A lot of options from here, and I could also, too, go deploy templates from Cloud Launcher, which is the cloud marketplace. And if I select that, it'll bring up over here, you see Kubernetes apps, and I could deploy these apps on top of those containers I just deployed if I so choose. With that said, there's a lot of good options for enabling our containers on Kube. We'll go through some additional areas as well throughout the class. And lastly, storage. If I want to have persistent volumes, I can take care of that as well. With that said, let's proceed on. Let's talk about Kubernetes Federation and how it comes into play, why we may want to federate, why it's important. So let's talk about federation and also discuss ingress as well. Now, we may want to federate for generally numerous reasons, but generally federation, the goal of federation is to essentially sync your resources across clusters. Federation is going to provide the ability to keep your resources in the cluster essentially in sync. Now, some of the benefits, of course, of federation can be availability, geographic disbursement, hybrid cloud connectivity, synchronization as well. Also, too, to scale to provide lower latency. And having multiple clusters, for example, on different cloud providers or on-prem can certainly provide benefits as well. So again, a lot of good benefits overall, but the goal is to simplify deployments. Now, when it comes to Kubernetes engine and actually just Kubernetes in general, whether it's on-prem or in Google Cloud, is that we want to, of course, ensure that we're able to bring everything together, that we're able to balance our workloads. Now, when we're setting up federation, there's going to be quite a bit to consider. We have to scale our clusters appropriately. We need to, of course, look at federation as basically a means to an end in the sense that we want to provide availability, efficiency, etc. But basically, when we talk about ingress, what this is doing is essentially providing a global IP, and essentially this is going to allow that service to connect essentially around the globe wherever the connection is available. So for example, if you have a cluster deployed, it will essentially deploy your global load balancer, of course, the service. And if there is an issue with your on-prem or cloud provider, it'll go ahead and route that traffic appropriately. Now, once again, it's based on essentially a single static IP address. Now, with federated ingress, it's going to automatically perform some of these actions. For example, matching objects in your cluster. So objects could be what? Pods, nodes, etc. Now, when it comes to ensuring that the objects, again, are the same, essentially, and that they're the right ones and that they are part of the cluster or clusters that are being managed, again, it's all part of just making sure that everything's monitored and available. Lastly, it really comes down to ensuring that the traffic is routed to the appropriate cluster. So if there's an outage or a pod goes down or a cluster, again, it's all about availability, really. And again, just making things available is really what it's about. So if you're just going to go ahead and deploy one cluster, then federation doesn't make any sense. However, if you're going to deploy multiple clusters and multiple providers, this makes perfect sense to do. So again, it's all about trying to scale and maintain capability. So for example, with hybrid cloud, whether it's Google or AWS, or even on-prem, again, we could deploy federation. Now, one of the tools that could be used is called Kubernetes Fed. This is generally the recommended way to deploy federated clusters. Now, Kubernetes Fed is Kubefed. If you're not familiar with it, take a look at it. But basically, this is a CLI tool that could be used to help basically set up and maintain your cluster. And essentially installing it is just basically going in and running some curl commands on your cluster nodes. And again, just setting it up. And you're going to run Kubernetes config as part of that. So there's more to the story. Setting up federation is not a 1-hour job by any means. Lastly, having a federation control system automatically reconfigures a load balancer in all your clusters and essentially makes federation consistent and also will share them globally. Remember, having that static IP that can be basically load balanced and routed to the appropriate cluster at the appropriate time is really the critical point to understand. Let's go ahead and move on. In this module, what we like to do is talk about the possibilities with Kubernetes Engine and the complementary services that go along with DevOps on the Google Cloud Platform. There's a lot to talk about here, but I'm going to make it short and sweet and to the point. I want you to think about a few things when you're considering DevOps. This information is good for pretty much as well if you're studying for any exams, such as the cloud engineer, developer, DevOps focused, whatever. Just the reality is even architect exam, this is really good for any of the Google Cloud exams. The reality is that they really need you to know DevOps and the tools that allow you to create a pipeline for your organization or another organization. So let's talk about this. Now, there's a lot of good use cases to have a CD pipeline, a CI pipeline, to have automated serverless deployments with like Cloud Build using Cloud Functions as your choosing function as a service method. But when we talk about Kubernetes Engine, and I'm going to bring up my pen here, we want to focus on two things. Let's go ahead and start out and talk about clustering. So for example, if I have a G Suite domain, and let's say it's company.com, make it simple, and we're already using G Suite and we have our Gmail used by the company and we have Google Drive and we're just using G Suite in general. We can extend that out to Google Cloud. And when we consider doing this, we of course have a lot of options from an IAM perspective. But we want to think of a few things as well. What about if we're going to use Kubernetes Engine and we want to cluster our services between, 2 or more projects? In this case, 3 projects. Now, what we want to consider is probably creating a VPC. Now, do we want to create a shared VPC? Again, logically, there's a few things that could be done. But basically, when we want to think about it from that perspective, and I'll get my pen here a different color so you could see, is around, and where is that thing? There it is. It's red. Okay. Now, the VPC is likely going to be shared. So what we're going to need to do, though, is we have our projects. So we have our 3 projects. And a shared VPC is essentially going to contain one or more shared network resources within a project. And of course, I have a project up here. And essentially, it's really under company.com. And under this project, whatever you want to call it, I have my IP, my subnets. And again, I could choose to do whatever I want with this. But let's say I create a shared VPC. The easiest thing to do is to create a shared VPC. And I could set up the correct IAM permissions, essentially, create my service accounts, ensure that the cluster administrator can, bring up any number of resources needed, inside the projects, and be able to monitor and manage the cluster as a whole. Generally, Kubernetes clusters are going to be in a service project, and they need to be configured with typically a primary CIDR range. Because we need that primary CIDR range, this is essentially, again, for the node IP addresses. We also need 2 secondary ranges as well for the pods and service IPs. So we have to think about the networking really seriously. So let me just write this in just for those folks that are actually, considering this down the road or studying for an exam. But we want to think about it from this perspective. So we need the CIDR basically, and we need to have the primary range basically for the projects. And then we need to have the secondary range essentially for our node IP. And we also need to have 2 additional secondary ranges basically for our pods and a service IP as well. I think I got that. And again, just think about it from this perspective. But when we take those 3 CIDR ranges and we put the clusters together, we essentially have what is called, and I'll put it right here, a shared VPC. And again, the networking part of this is literally another hour discussion to consider, to think about, especially if we're going to do a geographic deployment. We also have to consider ingress and egress charges, but also really structure IAM as well. But from Kubernetes perspective, there's complementary tools and services we may want to look at. For example, we may just want to, and let me get my pen again, a different color. And we may just want to create a pipeline. And generally, let's say we're going to do this on Google Cloud. We have a couple choices for our repository or source code. We could go ahead and put it on source repositories. We could put on GitHub, Bitbucket, whatever works. So that's going to be step number 1. Let me get my pen. Okay, did I not do that? There it is. Okay, sorry for the delay. Now, step number 1 is to basically get our source code. Step number 2, we have to build and test. And we probably want to consider cloud build. This is where we're going to go ahead and build our tester code. And then we need to manage basically our versions. And we probably want to consider, guess what? Container registry. And then we may want to put in here, again, depending on how you want to do this, we may want to, and again, room's a little tight, we may want to consider deploying like Spinnaker or something of that nature as well in our VPC. So let me get my handy dandy marker here. There's a lot to go into this. And then after we have Spinnaker, one of the things to think about too is our application. What's going to process our source code? What is the application that we're going to run, and where are we going to run it? Well, we could, of course, think about App Engine, our platform as a service. Cloud Functions is what? That's our function as a service. That's our basically snippets of code that's going to be a trigger for whatever we're trying to set up. And this could be used beautifully, especially in a DevOps environment. Then also, too, we're already using Kubernetes Engine, but we may also want to consider, for example, Compute Engine as well. And, again, we could put a block there for that as well. So whatever we choose, it's up to us to figure out how this is all going to work. Now, we do know that Kubernetes, when it deploys, is going to deploy the containers on what? Compute Engine, right? So again, we're effectively using Compute Engine when we're using Kubernetes cluster. There's a lot of moving parts in Google Cloud, just like any other cloud. And the reality is that there's a lot of options, a lot of amazing tools to use. What I'd like you to think about, whether you're going to do this in real life or for the exam, you need to realize, again, where Kubernetes fits in, how you deploy the clusters, and not just deploy the clusters, but how does the VPC go together? But also, too, how do you create a pipeline, right? How does this all work together? With that said, let's go ahead and move on to the next module. In this module here, what we'd like to do is install the software development kit. Now, there's a few different ways to get to it. We could go up over here to our utilities and go over to downloads, or we could also go, if we scroll down, to install the SDK as well. Also you could do it via App Engine as well on a couple other locations. But in general, pretty much just go install the SDK. This will bring us over to the SDK webpage. I'm running Windows, so I'm going to go ahead and just leave it as install for Windows. What I want to do now is I want to, since I have a project created, if I go back, you can see that I have 2 projects. What I want to do is go download the installer, and your antivirus may pop up saying, do you want to install it? Again, go ahead and select Run. And I'm glad it's safe. So I want to go Next. Read the license. I'm going to go ahead and install this just for myself locally. Director will be next. Now, one of the things to point out is that when you install this, it's going to ask you to install other components. Now, you could install the bundle Python that's available with it. You do need to have Python installed locally for you to be able to run the SDK locally on your desktop or your Linux box. There's PowerShell tools that are available if you want to use that. And then beta commands will be basically commands that are fairly new, but they haven't, went into production mode. So select install. Now I had this installed before, so I uninstalled it. Generally, there isn't any issues I've run into after uninstalling it, except for once I did have one issue. So if you do get an issue, you may need to go in and validate it did uninstall. You may need to go into the Windows uninstall program and double check it is gone. If not, there's directories under programs you may need to remove. It's installing the components. You go show details. This will show you what it's doing. As you can see, it's installing components. And if I scroll over, it's got the app data, and then it's also showing you the tools that have been deployed. So you can see that it's also installed the BigQuery command line tools, as well as the CLI dependencies, etc. And it also installs SSH. Okay, so it's still installing, and we will let it complete and come back and check on it. Okay, it completed. Let's select next. We do want to just validate whether we want to install our start menu shortcuts, our desktop shortcuts, the shell as well when we start it. Do we want to start it immediately? And then we do need to run global, gcloud init. Now, gcloud init, you don't have to do it right now. You can do it later when you bring it up. But basically, that command is going to go ahead and initialize the cloud shell. And this will help identify what project and regions and zones you want to connect to, and then log into Google Cloud. So let's go finish. Now, let me just adjust this so you can see what's going on as efficiently as I can. Looks like that'll be about as good as I'll get. Okay, now, what I'd like to just point out is you can see that it brings up some choices for the configuration to use. Because I've had other configs, it pulls up those as well. But what I want to do now is I don't want to use a previous one. I just want to create a new one. So I'm going to go select 2. Now, it says basically enter a configuration name. What we want to do is enter a config that hasn't been utilized before. So I'm going to call this, let's say, GCP Training DevOps. Going to go enter. So now it says it's been set to GCP Training DevOps. And basically now it's saying, what is the account I would like to use? Well, I'd like to use number 2. And it says I am now logged in to that account. And now I have to select the project that I want to use. And I could either create a new project or select an existing project. So I'm going to go ahead and select GCP Training number 1. But before we do that, let's go over to the console and validate what we have. So let's go over to projects, and it says GCP Training 230220. So let's validate what we have. And that is a good project. So let's go ahead and select 1. And after we select this, what's going to happen is, let's say, for example, we're working in a specific zone all the time. Our programs, our cloud services are in Iowa. We have the ability to select a default compute region and zone if we want. In this case, I'm going to go no. I don't need to do that for demo purposes, but if you want to, select yes. And you can see that it's pretty much done. Now, after you read all this, basically, it says if you need more help or you want to play around, type the gcloud-help command. But let's do this. Let's go type gcloud and then projects and list. What this will do is list my current projects. And you can see that I have a project giving you the project number, project ID, and project name. And with that said, that's pretty much all you need to do to set up a SDK locally. So I'm logged in. I'm already in the project that I want to be. If I want to do anything else, for example, then what I want to do is make sure I know the commands to change, for example. But to do that, if we have help issues or don't know what we're doing, type gcloud-help, of course, this will give me the flags and the commands and syntaxes that I may want. And let me go ahead and get out of this. Now, let's say just one more quick command before we continue on. Let's say, for example, I want to, let's say, let me move this up here into the middle of the screen. And let me adjust this so you can see in the middle of the screen as well. Okay, so let's go gcloud. And let's say I want to know, for example, my available compute regions, let's say. So what I would do is type gcloud compute space zones and then list. And when I enter that, it'll bring up the available zones and regions. So I would recommend that you do set your zones and regions, especially if you're going to be tied to a specific zone and region. It'll save you some time and hassle down the road if you're not paying attention. But once again, that's really all you need to do to get started with the SDK. It's very intuitive in the sense that the commands in gcloud are straightforward. There is a page you want to go look at. For example, go to Quick Start for Windows and scroll down here to the gcloud reference. And then over here, you can see that there's different commands. For example, these are going to be the commands you could type for pretty much any service or any requirement that you need. Like gcloud version, if I want to know the version of gcloud that I'm using, it'll go ahead and list the version that I am running. With that said, I go over to gcloud source, and version is listed here. So if I go gcloud version, it'll go ahead and list that. If basically list what we have. And there's some flags that could be used, but in general, gcloud version, and then any flag that we want. Pretty straightforward. Okay, let's move on. I'm over here in the Google Cloud console. What I'd like to do is show you what Cloud Shell is. What we want to do is just go over here and select Activate Cloud Shell. Now, before I activate it, let's just talk about what it is. Essentially, Cloud Shell is an ephemeral virtual machine that's going to spin up inside of Google Cloud. And what we want to do is just bring it up and just to validate our project that we're in. To do that, what is actually going to happen is because we're already logged into Google Cloud, I don't have to go over here to my desktop and log in to my virtual machine over here to do anything in Google Cloud, because this is running locally on my desktop. Because I'm already logged in with the browser to Google Cloud, when I click this is going to bring up a shell, and it'll provision this instance, which is ephemeral. Once you bring it up and you bring it down, it's gone, nothing's saved. So that's really what I mean. But with that said, let's just go ahead and check out our projects that we have available. So I want to type gcloud, and then I check projects, and again, make sure you type in the plural. And you can see that I have two projects. One is called My Project, and the other is GCP for AWS. And again, this is Cloud Shell. Just be aware that it's an ephemeral instance that could be useful for you when you're managing Google Cloud or setting up stuff, or just want to view the status of something, to go in and not have to log in with the SDK, especially if you have VPNs, you got to go through stuff like that. And it could be a little bit more time consuming for some corporate environments. And this may just work just fine, especially if you're just going to run a few commands. So you can run your gcloud commands via what is called Cloud Shell. Let's move on. Let's talk about Cloud Build now. Now, Cloud Build is an application. that Google Cloud has come out with to really enable developers to build, test, and deploy applications in the cloud, specifically Google Cloud. Now, what we want to do is go down here and go over to Tools, which is right here, and then select Cloud Build. Now, you can see under build history, I have 2 builds. One failed, one was successful. When I go over here, you can see that it tells me the build ID, tells me any relevant information, the build steps that it went through. Looks like this was a Python app, Flask, yep, PIP, there it is. And again, you go ahead and sort through that. Now, I could also create a trigger, and a trigger is sort of a cool thing because that's going to let us basically create essentially like what's called a webhook in the web world. Basically, it's just a trigger that's going to kick off when a requirement is met. For example, if you have development groups updating the repositories and there's any changes that are sent out, it'll set a trigger based on that GitHub or repository that you select. So that's really cool. So if it matches what you set, it'll go ahead and kick off and automatically apply those changes to the image. So again, fairly straightforward. So let's create a trigger. Now, this, I believe, is still in alpha mode or beta mode. Yeah, it's in beta mode. So generally, my experience with beta mode solutions is that they're usually pretty good, but you may see some inconsistencies, especially with some of the features. Sometimes they're there, sometimes they're not. But in general, they work pretty well. Usually, it seems like with Google Cloud that these additional services that are in beta mode or features as well could be in beta mode for 6-7 months sometimes. So don't take it as like it's unstable to use. It's just that the level of support that's provided versus a production ready app is a little different. Anyways, so I think this is actually worth looking at. So let's go ahead and create a trigger. What we want to do is we have a couple choices. I could have it, basically look at source repositories, my Bitbucket, or a GitHub. I'm going to go ahead and select repository. I'm going to go continue. Now, it actually found my repository that I had copied over from GitHub, and I'm going to go continue. What it's going to do now is it's going to allow me to set basically a trigger based on the variables that I want to put in the setting for. I could basically have it build the configuration either or with Cloud Build. I could use a Docker file as well. And again, I have several choices. I could also match any branch. Now, in the cloud source repositories module, I showed you how you could figure out the branches. There's a drop down here that'll tell you, so you could select what branch of that repository that you want to basically trigger on. So I go over here and configure that however I want. I could basically specify the config file, etc. There's a lot more to this. I just wanted to go ahead and create a quick trigger to show you. And now I have my trigger, and it's pointing to the Marbles application right there that I copied over from essentially GitHub to Cloud Source Repositories. With that said, I could add another trigger, and I could select again Cloud Source Repositories. I could select the same one if I want, create a different trigger. I could just go back, add a trigger from GitHub, and then it basically will ask me, do I consent? Go continue. And you can see that'll bring up the repositories that are available. Go continue. And again, I could go create a trigger based on whatever requirements that I so choose. With that said, simple enough, I think, for now. Let's go ahead and move on to the next module. Now, there's another service called Container Registry. Now, this is a service that could serve a good purpose in the right situation. So if you scroll down over to the left here, you'll see we have Container Registry. Now, to use Container Registry, what we want to do is upload images from our local environment to Google Cloud. And basically, this is going to store those images on the Google Cloud platform. Now, we could also take images that are on Google Cloud and move them over to our local environment if we so choose. And then as far as settings, there's, again, the main purpose of this is to allow you to scan for vulnerabilities. This is still in beta mode at the time of writing. And then we could also change permissions as well to have images available to the public if we so choose as well. Now, I don't have any registry set up, but if you did want to do that, you'd want to take some of your images from your on-prem and just load them up. There's instructions on how to do that. It's called pushing an image. You'll need to, of course, use Docker. Make sure that it is the proper configuration for that as well. And if you scroll down here, it sort of walks you through a lot of these areas. Most of the errors that I've seen in the past have been generally just a result of not paying attention to the Docker commands. Now, what is also interesting is if you go here to tags, for example, especially in a large environment, you can go ahead and find your images in storage as well by tagging them. So if you tag the image, again, pay attention to what you're tagging, but also how you call it in the image upload or download, depending on what you're doing. With that said, this is essentially Container Registry, if that is of interest to you. Now, in this demo, I'd like to walk you through what Cloud Source Repositories is and how you could connect, for example, your GitHub to the Google Cloud Source Repositories. So what we'd like to do is go to the console and then go down to where it says Tools. Let's go down to where it says Source Repositories. Now, this is going to bring us over to a separate page. You can see that it goes out of the console. Before you get started, I'd advise you to read the documentation. Basically, this is going to be a GitHub on Google Cloud is what it is. It's going to allow you as a developer to develop and maintain your source code locally in Google Cloud. You can connect up still to your GitHub or your Bitbucket, whatever you're using and is supported at the time. I do know that down the road that they'll add more capability. There's still a lot of functions that are still sort of what I would call in beta or alpha mode. But let's go ahead and get started here. And I'm going to go ahead and create a repository. Now, we have two options. I could create a new repository, or I could connect to an external repository. Either or, if we go to new, it's going to ask us to call this whatever we want, and then we go through and create. What I'd like to do is in this exercise actually connect to my GitHub and just show you how that works. So let's go ahead and go continue. Well, I want to select the project that I want to tie in this external repository to. I'm going to go ahead and select the one that I was working in. I could also create a new project as well. That would probably be recommended because if you create a project, That's going to provide essentially, some pretty decent, what I would call protections, in the sense that you don't, if you don't need to, try not to keep this in the same project with your production and other QA apps or whatever you may be doing. Try to keep this in a separate project for segmentation purposes. Remember that projects are not only a way to maintain separate billing, but also, or not just separate billing, but what I'm trying to get at is that it's a manner for you to be able to protect not only your resources, but also your billing and management of your billing. So a lot of great benefits there. All right, and then what I want to do is select the provider. I'm going to go ahead and use GitHub. Now, what's going to happen here is I've got a consent to allow cloud source repositories to connect to GitHub. Now, it basically gives you some best practices, some information here as well. It's going to use open authentication, so it's going to go ahead and connect to GitHub. And it says, go ahead and add my username and password. So I'm going to go ahead and add my info and sign in. And it helps to type the right password. Now, as you can see, I have my information here, and it's basically saying it found my account, found repositories, and as well my organization. So I'm going to go ahead and authorize this. You can see it's using OpenAuth at the corner. Now, you can see that it brings up my repository here, and let me see. Let's go ahead and pick one of these with some chain code in there. So I'm going to go ahead and select that. And then let me maximize my screen here a little bit because it's a little bit hard to see down the bottom here. Give me 1 second to adjust. Okay. Now, you should be able to see this now. Again, I have a limited screen space for best resolution. So let's see. So I'm going to go ahead and just select, let's see. Let's select one of the marbles ones. Okay. So marbles is essentially a Hyperledger Fabric demo application that I could just use. So I'm going to go ahead and connect. As you can see, it's fairly simple to do this. And it's going to take a little bit of time. It's warning us, as you would expect. So what it's going to do now is it's essentially going to connect. And it's sort of similar to what you would do with GitHub, is you'd fork over your GitHub back over to your GitHub repository. And this is essentially what it's doing. It's going ahead and forking over that specific repository that I selected. So we'll come back to this when it's done and check it out. Okay, so my cloud source repositories, basically the repository that I cloned from my GitHub, the Marbles app, is right here. It did copy over. It took approximately 25 minutes to copy this all over. It's probably about 80 to 100 meg from what I remember. So it's fairly good size, so it definitely took a little time. And I go over here, look at a source code, and you can see that's in Go. So pretty cool. I'm able to bring over a repository. I could also search it as well. And then if I want, I can also open this up in Cloud Shell. And you'll see that when it opens up, I'll be able to edit this in Cloud Shell. And so you can see there it's cloning this and bringing it all up. It's unpacking it. With that said, this is going to take a little bit of time. So you can see that it has my source code there, my Python doc samples, app engine is copied over as well, Node.js. So that, again, it's pretty cool. So I'm able to do a lot with this automatically, essentially. And you can see that it brings over samples as well. Okay, so I'll go ahead and leave that. So I have my cloud source repository copied over, and this enables me now to tie in other services, which is actually really cool because now I could go use Cloud Build and then deploy from here if I want. With that said, that's about all that I had with this. You can see that I have my source code over here, chain code that is, for a blockchain application. And then actually a couple things to point out too. You can see there that I have different branches. If I click there, you can see that the branches for this was basically deprecated essentially, and it keeps track of all this automatically for you, just like you would expect on GitHub. And if I want, I can go back to GitHub, and it brings me over to that application that I just copied over. With that said, let's move on. Hopefully this is useful to your pipeline. With that said, you can go ahead and play around with this as well. I'm over here at the tools webpage for Google. Now, as a developer, you definitely want to go to this page and validate the tools here that are available for you as a developer. Some of the common tools that you may want to use will certainly be around plugins or some of the tools for IntelliJ or for Eclipse, depending on what you're doing. Especially if you're using Java, you may want to use these. It also supports Android Studio as well. And then the other tools that we just went through during the course. Now, as far as tool sets, this is not an exclusive list. I would definitely go to the marketplace and look for new things that might be added as well that you might be able to deploy, such as like deployment tools such as Jenkins, CVS tools that might be available, whatever you may be looking for. With that said, let's move on. Well, let's talk about what microservices are and why they're important. Now, generally, microservices is going to be an area as a developer you're going to definitely run into. There's a couple options on how to deploy microservices. Generally, the two accepted services in Google Cloud would be Cloud Functions or App Engine. Generally, the best option would be Cloud Functions for a lot of different reasons. But generally, what is a microservice? A microservice is going to be an architecture that is going to enable you to develop software that is going to really build in single functions. And what that means is instead of typically building an application with all the services and programming all in one encompassing application, you're developing a lot of mini services that are going to be independent of each other. And this provides some benefits, there's no question about it. Because of that, it can enable scalability, make it easier to test and validate issues that are going on. It can make your services more agile. But once again, microservices, it's sort of similar to, instead of going out there deploying a whole application at once, you're deploying little snippets of code, individually. And again, it also provides some benefits around distribution. But anyways, with microservices, the benefits and the pros and cons and challenges will vary widely between different organizations. But anyways, Microservices, the benefits could be the fact that they're simple to deploy, simple to understand, they're reusable. They can also isolate defects and also basically provide insight into what exactly is a challenge. So if you have an application that is doing a query and you have microservices, it might be really easy to figure out what query is doing that. Whereas in a typical application, there may be several components laid on top of that, and it may make that troubleshooting slash risk mitigation harder. Now, some other characteristics is, again, it's going to have multiple components. It's built for business, simple routing, it's decentralized, failure resilient as well, and it's evolution. In other words, you can build on top of it really easy. With microservices on Google Cloud Platform, you mainly want to deploy them on Cloud Functions or App Engine. You could also deploy it on Kubernetes Engine as well, of course. But with that said, it really depends on the use case. Each of these services are going to have pros and cons around what exactly you're trying to do. So, for example, Cloud Functions is a managed serverless microservices platform. It's really meant for deploying snippets of code. App Engine is more of a development platform, and Kubernetes is more of a container service. So let's go ahead and wrap this up and continue on. When you deploy your microservices on Cloud Functions on App Engine, you could certainly deliver value by focusing on your code instead of infrastructure and operations. Let's talk about Cloud Functions. Now, Cloud Functions is a really nice service. It's very comparable to AWS Lambda. Now, when we look at Cloud Functions, we want to realize that, again, this is a real specific use case to want to use this. But basically, it's a serverless execution environment really meant for building and connecting cloud services. Now, Cloud Functions is fully managed. It's going to basically use what's called a Node.js execution environment, and it's going to run your backend code. Now, one of the things to keep in mind is that generally with Cloud Functions, you're going to want to write a trigger that's going to respond to events in your application or your project that you're doing, or whatever the microservices use case is, right? But once again, it really just comes down to understand that Cloud Functions, you don't have to worry about managing instances of servers or scaling up and down. It's going to be essentially automatic. It's all handled for you because it is a managed service. Now let's just talk about App Engine, because sometimes there's a little confusion between App Engine and Cloud Functions on, can they do the same or can they not? But basically, App Engine is much more flexible. And again, with Cloud Functions, it's running a Node.js execution environment. In App Engine, you're going to choose your runtime environment. You can also deploy Docker with flexible environment as well. But with that said, it's going to scale much greater. But if you're just looking to have a managed Node.js environment that runs your backend code, for example, like for Firebase, if you're developing mobile apps or something of that nature, then maybe Cloud Functions is really where you should go. But with that said, when we look at making a decision, it's really about the differences. So remember, Cloud Function is a single runtime environment. It's really meant for lightweight, standalone projects. Another thing to keep in mind, too, is that it's not really meant to handle complex apps like App Engine, whereas App Engine you're going to develop your whole app on. Cloud Function is really meant to run snippets of code, microservices essentially. So I hope that made a little bit more sense. So basically, Cloud Functions use this as a way to run code simply. It's a managed service. It responds to events. Also, too, function as a service. It's basically considered a function as a service is another term you may hear. Now, when it comes to Cloud Functions, it's event-based. Triggers are going to be basically with Cloud PubSub, web, or cloud storage. The code will deploy functions from like a cloud storage bucket, a GitHub, Bitbucket, etc. It's written in JavaScript and runs in Node.js. It does have Stackdriver integration, and there's two variants. There's a foreground and a background variation. So depending on the service that you're going to run, you could choose between the two variants. So let's go ahead and take a quick look at how this works. So basically, from an application perspective, we're going to have our cloud services, our cloud functions, and then APIs. So for example, if something in the cloud services, let's say if we're using cloud storage, somebody drops something in a bucket and it picks up an object. That object could then be set up to trigger, let's say there's a new object, it could trigger an event, and Cloud Functions would then execute that and perhaps drop something else back in the bucket, let's say. So it's going to respond to events. So a lot of good use cases for it, but again, the limited use case for Cloud Functions, so that it makes it real easy to decide if you can use it or not really quickly. Now, with Cloud Functions, for example, it's going to basically, you're going to really concern yourself, for example, with triggers. Now, a trigger is what? It's going to be an event or some kind of data as a result of an event that you're going to want to be notified about. For example, if someone goes ahead and goes to a website and you see, for example, the chat box that pops up, that's really a trigger. So when you go to like the home page, you get a chat pop up. There's basically a webhook, for us old folks when we develop web apps. Basically, it's called a webhook. It's really a trigger that's responding to an event. That's all it is. And with that said, you're going to look at triggers and event data as well, pass it off to Cloud Functions, and then it'll execute whatever you tell it to execute. Now, for example, if we want to use Firebase, we could use Firebase for our mobile solutions and extend capability. With that said, it's going to allow us to run serverless functions for our mobile events and applications, basically with our Firebase database. So if we want to kick it off with Node.js, we can leverage those capabilities. Very flexible service. So let's go ahead and take a quick look in the console at it. Now I'm in the console here, so what we want to do is go down to Cloud Functions under Compute. Now when we first initialize Cloud Functions, we're going to, of course, have the API installed, but then we need to create a function. Now we have a couple options. We can, of course, select the memory. Now remember, we could choose how to trigger this. It could be web, it could be cloud storage, it could be Firebase. Also, fairly new is actually Google Analytics. But with that said, it's up to us to decide how we want to do this. So we call this function 1 or, test function 1, whatever is appropriate, right? We could use source code editor. We could zip load it from repositories if we had something set up. We could zip from cloud storage and, again, upload as well. Now, the runtime environment, again, is generally Node.js, but it has actually been expanded to Python and Go to a degree. But again, limitations there, so do read the docs. And then function to execute, basically, again, you're just going to notify yourself. For example, if someone goes to your website, basically say, pop up the chat box and then say, how can I help you? So this is just one example. And then you go ahead and create a function. And again, that's going to be a web-based function. And all I'll do is execute a hello world execution. For example, if I had an application I want to set up a function on, I would just direct it towards that. And very simple to create a function. But again, it's all about the use case with Cloud Functions. So let's go ahead and move on. Let's talk about Stackdriver. Now, Google Stackdriver is a hybrid monitoring solution. It supports AWS, but it has also basically other features and functions that could be very useful in troubleshooting or identifying issues in your cloud platform, and can certainly be used actually quite well when it comes to logging and monitoring, for example, with auditing. So let's go ahead and talk about Stackdriver in that regard anyways. Now, Stackdriver Monitoring is a hybrid solution. It was basically a company that was bought by Google, and at the time they monitored AWS and they monitored Google. And that's how that purchase came to be. Now, what's really nice about Stackdriver is that it supports multi-cloud, of course, but it's really meant to help you identify issues and to fix those issues as quickly as possible. It certainly aids with cloud security and for compliance requirements. So when we look at Stackdriver, it's really a portfolio of services. The newer feature actually is Profiler, which isn't there, but just be aware that Profiler could be used as well. But basically, we create a Stackdriver account for a project or projects. We can monitor with a single account as well. Now, Stackdriver has the ability to ingest data metrics, and then that allows you to derive value from those metrics and determine, for example, who accessed what or what kind of latency is going on. So a lot of big deal around that from a security perspective. Now, quickly, there's basically the ability to install the monitoring agent. It's recommended, if you can, to install the agent on your Compute Engine instance, just because you'll have a lot more access to custom and also extended metrics as well. With Stackdriver, it uptime checks the location, so you can essentially be aware that your services are available. There's also two firewall capabilities as part of Stackdriver. Palo Alto is supported. There's also other monitoring solutions you could use, like Nagios. If you go to the cloud marketplace, there's a good amount of options there to consider. Now, when it comes to logging, monitoring is one thing, but keeping track and documenting what's going on is another thing. So we want to look at essentially the ability to retain our activity, and we want to use what's called logging. Now, generally, Stackdriver maintains the logs for 30 days. If you need to maintain them beyond that, make sure you dump them off to cloud storage. But also note too, what you could also do is save them in cloud storage and then analyze them, for example, with BigQuery. So you get alerts on log events as well. So for example, if you want to know when someone accesses a VM, it can notify you of that, or if someone modifies a cloud storage object. Here's a command to install the logging agent. Now, a couple of things with logging. You don't generally want to use substrings. For example, don't try to make it more complex than needed. Set up filters. So just set up, basically a search for what you need. This will minimize a lot of issues. So if you want to search and analyze, export to cloud storage, and then use BigQuery to search and analyze. You could also visualize this with what's called Cloud Data Lab as well. And then if you want to create a stream to document this to other services, etc., use Cloud PubSub. Then we have reporting. So reporting, again, is very similar to what logging can do, but basically the goal is to notify you of what is going on. Error notifications. It'll pop up via email. You could have PagerDuty notify you. Scripting, whatever you want to do. Then we have Stackdriver Trace. So Stackdriver Trace could also be used to analyze issues in your code, to discover bottlenecks, generate reports. Your developers are likely the ones that are going to be using this. As part of this, you'll probably want to look at latency issues. You could also look at performance issues as well, but generally the main goal is to collect data and identify latency issues. With debugging, this is a way to inspect applications and not have to stop it. Now, one other thing on Stackdriver Trace is that you could visualize your data as well, and that really helps developers to identify what's going on. Now, with debugging, you take a snapshot of log points so that you go back and analyze the code. For example, if you're getting latency at a specific time, that allows you to basically go back and really work on what's going on. So that's really about all that I had to cover in Stackdriver as far as slides. I'd encourage you to look at the Stackdriver demo where we set up alerts, and we'll continue on. Let's talk about service accounts on Google Cloud Platform. Now, as a developer that's going to be rolling out apps on Google Cloud, you're going to definitely run into service accounts and understand the requirements around why we want to deploy service accounts and some of the permissions and requirements and considerations for that matter. So when it comes to provisioning accounts in Google Cloud, there's different types of accounts. For the purposes of this course, I won't go into basically anything else but service accounts, so like G Suite or Cloud Identity. But basically, in reality, we want to deploy a service account basically as a way to establish identity. Now, generally, a user account we're going to use to, like, for example, user account would be a Google account, a Google group, G Suite, etc. And those type of accounts are going to identify a person. But we need to identify a service, basically, and allow our API, for example, to access Google Cloud Services. So a service account is an identity for your programs and allows them to essentially authenticate and gain access to the GCP APIs. This is for server-to-server communications. And these service accounts will authenticate, again, to your VM instances to other services. So when you're developing your apps, this is going to be part of that information you're going to have to collect to add to your application, especially if it's like on-prem trying to access Cloud SQL or any other service like Compute Engine, etc. As part of that, to identify the service account, you could always tell a service account because it'll have an email at cloudservices.gserviceaccount.com. That's the simplest way to identify a service account. When it comes to service accounts, again, it's meant for server-to-server interaction. Generally, when you consider your applications, you want to understand that that application needs to have that API and establish basically account credentials. So you'll copy and paste that information into your program. It's going to essentially request a token, and it'll be Open Authentication 2.0. Now, that application, of course, will access a token to call the Google APIs as well. And the format will be JSON or P12 format. Some notes to consider when, for example, you're using G Suite Marketplace to install an app. One of the things is you'll need to understand the permissioning behind that. Another thing is you don't really need to manually authorize accounts because, again, when you create that account for that application use, it should be already, from a permission perspective, ready to go. And you could also delegate domain-wide authority to a service account, but from an application development perspective, you don't want to do that. There could be reasons, but in general, that's something you probably want to leave up to your cloud administrators. When it comes to service accounts, just some other notes to consider. Generally, users are authenticated with email and passwords. Service accounts are authenticated with the key file, so there's a difference in the process. One of the things to consider, too, is you could lose your key file. If you lose your key file, that means someone could, of course, get in via your program and access the resources. So that's something to think about. But basically, if you're going to create a service account, you do this via the IAM administration section. Now, some other operations would be edit, delete, create key, and modify. I won't go into each of the details for this course, but these are just some operations that you'll be familiar with. Now, I do have a demo of creating a service account in the bonus section of the course at the end. So if you want some help with it, it is also there for you. So when you create a service account, you assign it to one or more user accounts if you like. But also, too, again, it's really meant to do what? It's to allow developers to essentially access virtual machines and Google Cloud. Let's go ahead and move on. Let's talk about cloud endpoints. Now, cloud endpoints is essentially an API gateway. It's really the on-ramp to Google Cloud. Now, cloud endpoints is going to be, of course, integrated with Google Cloud. It's an API proxy that is built into App Engine. And you can also, of course, extend it out to Kube Engine as well, if you like, via what's called the YAML format, if you so desire. But basically, Cloud Endpoints is going to extend your on-ramp to GCP. Now, it's very comparable to the API gateway in AWS. There are some differences, of course. GCP does support basically Open API, which is something that AWS does not. One of the challenges, though, that I generally run into, at least here, is that Cloud Endpoints does not really have a very good user interface. There's no question you're going to want to, of course, use the CLI with Cloud Endpoints, so you need to be a pretty decent developer to use it. Couple other tidbits on endpoints. It is an API gateway. It's an Nginx-based proxy, essentially. You want to use it to create a web backend for your web clients. You can deploy this with App Engine. Tools and libraries are with it as well. Now, here's an example of how endpoints work. You're going to go ahead and have your server. You're going to have your proxy and your endpoints here, and your clients will be, of course, extending out to the proxy. Some of the features are listed here, such as key generation, integration with OpenAPI, automated deployment. And here's another example of how a mobile backend would be utilized with App Engine. And so you have your mobile clients on the left, basically accessing cloud endpoints and extending out to App Engine as well. And then we consider cloud endpoints. Again, the goal is to develop, deploy, protect, and monitor your APIs with cloud endpoints. Remember, it's an Nginx-based proxy and a distributed architecture and provides extremely good performance and scalability. Let's go ahead and move on. Let's go ahead and talk about Deployment Manager. Now, Deployment Manager is Google's infrastructure as code solution. So let's go ahead and talk about it briefly and then go over to a short demo. Now, when it comes to Deployment Manager, a couple of things to point out. Basically, this is our infrastructure deployment service in Google. As a developer, you'll likely be using this. Just be aware that it is a declarative format for schema files and YAML for the as well. And it uses essentially for templates, Python, and Jinja 2. Now, when it comes to deploying a configuration, essentially, or deployment actually, basically you go ahead and configure all your resources in one deployment. So if you want to go ahead and deploy Compute Engine and you want to deploy cloud storage and you want to go ahead and deploy Bigtable or SQL Services or Cloud Pub, you can put everything together in a YAML configuration and go ahead and deploy that all at the same time. So let's go ahead and take a look at it. Now, we had previously deployed Jenkins, and I also deployed a WordPress as well. So what I want to do is go over to Deployment Manager. And basically, there is, of course, a couple different ways to get to it. And it would be under Tools, for example. Here we go search for it here. So let's go ahead and click Deployment Manager here. And you can see that I have two configurations already deployed. I have Jenkins and I have WordPress. So let's go ahead and look at Jenkins since that's the one we deployed during this class. Now, when we deployed this, we used Cloud Marketplace to kick everything off. However, we could also go in and create our own YAML files and set up our own config and services if we want. But one thing to point out is if we go over here, we could go ahead and expand or contrast. We could look at our VM.py, which is a Python file, look at our instances over here, and then we have a firewall set up as well. Then if we want to go over here and look at template properties, when we scroll up here, you can see that it says Jinja right here, Jenkins Jinja. If we select that, what will happen is it'll go ahead and show us basically our template. And if you just look at this, you'll see that it's calling essentially service accounts. It's tagging essentially our ports. If we scroll down here, it has our outputs, for example, as well. So there's a lot to Deployment Manager, very powerful tool. And as far as like when we select type registry, if we had composites set up, we go ahead and do that. Basically, we go ahead and create our own templates and then upload what is called a deposit. Basically, it's a template and schema file, which is called a composite. So if we want to go ahead and create that or copy when we could, there's plenty available on GitHub as well. Google has some available as well. And if you take, for example, any of the classes, for example, with Google, they have some available they provide as well. But if you did want to go ahead and deploy a template, it's easy to do with Deployment Manager. So let's go ahead and move on. In this solution here, we're going to go ahead and deploy a Cloud Launcher WordPress application. Now, Cloud Launcher is actually now known as Marketplace. This is just renamed. So what we want to do here is just go over to the left pane, select Marketplace. And now what we want to do is go find WordPress. Now, WordPress, the one that I want to use is the Click to Deploy one. And I'm going to go here, select Click to Deploy. Now, you'll notice here that this is the estimated costs over here to run this instance for 1 month. Over here is what is going to be installed, the package contents. This is basically a LAMP stack is really all it is with WordPress running on it. Let's go ahead and deploy this. So what I want to do is launch on Compute Engine. I'm going to call this WordPress 2. The one thing you have to do is put in an email there. And I can adjust the firewall if I like as well. I could change the boot disk. I could change it to an SSD as well. Now you'll notice the cost is $24.67 per month. If I change it to SSD, the cost goes up to $25.97 per month. So anyways, just to be aware of that. Could also install PHP Admin. This is a tool that could be used with MySQL, specifically for database management. I'm going to go ahead and skip over that just for test purposes and deploy it. Now, this is going to kick it off, and what will happen is it's going to create a deployment manager template. And during this process, it's going to go ahead and launch the LAMP stack. This will take approximately 5 to 8 minutes to complete based on what I've seen. So we'll come back in a few minutes to see how it's doing. Now this completed in about 4 minutes, so it wasn't too bad. Now what I'd like to point out here is you can see that it has a site address here. It's got the admin URL here. It's got the instance name here as well. I could also launch the admin portal. It also gives you some next steps to set up, for example, an external IP address if you want a static IP. Now, you'll need a static IP, especially if you want to deploy this commercially, for example, or you may want to use App Engine Security Scanner as well. Let's say you're going to go ahead and update your WordPress app and make it more secure. You can do that, add layers to it, whatever you want. But to use Security Scanner as well with Compute Engine, you need to have a static IP. And that's a static external IP, that is. Let's go ahead and click on the link here. This is the site address. When we click on it, that'll bring us over to a WordPress default web page. And this is your Hello World web page. All right, now what we want to do is let's go over to Compute Engine. I'm just going to go ahead and select that, go over to Compute Engine. And you can see that this is green. This is actually running, and that's what that means. These other two are stopped. They're not running. And you can see that WordPress 2-VM has been deployed. So that's essentially how you deploy a Cloud Launcher application, or now known as a marketplace application. These are essentially templated applications. They're stacks of applications. In this case, it's a LAMP stack running WordPress. And you have the ability to deploy that pretty efficiently and easily. Let's move on. I'm over here at the Qwiklabs website. Now, Qwiklabs is essentially a website that has integration with AWS and Google Cloud Platform. This essentially allows you to practice on AWS-related labs and Google Cloud Platform labs. This is a really great tool for those that may not have hands-on experience and would like to be guided through essentially a specific task that is part of a lab. If we go over here to Catalog, you'll see that there's quests, and these quests are essentially related to a specific job role or a specific area of the cloud, like machine learning or cloud architecture. If we select cloud architecture, you'll see that there's 10 labs that are included, and it costs 64 credits. Now, to get credits, there is a cost. So if this was of interest to you, you should expect to pay around $64 a credit, or there's a subscription that you can also get as well and use the unlimited lab approach if that makes sense for you as well. But if you go down here, there's Cloud IAM. That's related to the cloud security course that may be of interest. And then if you scroll down here, there's key management as well that might be of interest. And again, deployment manager, other areas that could be of interest to you. If we go over here, you'll see that there's data engineering, data science. And if we scroll over here, there is additional labs as well. Security and identity. This one here would be directly related to the course that you just took. There's 9 labs that are included, and the credits is 40. So you're looking at about 6 hours of labs. The reality is that this is the time they give you, but you'll likely get it done in 3 or 4 hours. It doesn't typically take as long as that. And you can see that there's security scanner, there's service accounts, VPC peering, data loss prevention, KMS, setting up a private Kubernetes cluster, and setting up a VPN. With that said, I just wanted to point out Qwiklabs for a resource for those that don't have a lot of hands-on experience. There is a cost to this, though, that you'll have to fork over. Like I said, it averages typically around $1 a credit for the quests. But with that said, there is a subscription as well if you want to go look at the pricing. I believe the pricing is the same for every geo. I don't know that for a fact. I do believe in Europe, though, the pricing is different because of the VAT taxes, but I don't I don't know. You'll have to look at what Google is showing you from your domain, essentially. With that said, Qwiklabs.com, an amazing resource that's available to help guide you through setting up and performing specific tasks in GCP. Now, one resource that I would encourage you to use if you can, from a budget perspective, is called Qwiklabs. Now, this is not a free service. There is generally two options available. You could subscribe to it, or you could just pay by the lab, for example, and by a certain number of credits. Now, this service not only supports GCP, but it does support AWS as well. So, for example, if you did want to go and look at data engineering, you go ahead and look at what is available. This is a quest. If you wanted to take the quest, it's 10 steps. It's about 7 hours worth of training, and it costs 53 credits, which works out from the last time I seen was about $1 a credit. So you're looking at $50. Now, if you join, you go ahead and join and select, for example, the right subscription model for your use case or just buy credits. I'll leave that up to you to determine as well. But if you go here to the search button, this will pull up the different Google Cloud Qwiklabs that are available when you go and select that. So this will bring up, for example, the most basic class is the fundamentals class. And basically the way this works is that this will give you 12 hours, 7 labs, and you go ahead and take this on demand. And this will bring you over to here. And as part of the specialization for this, there's labs included. So this is like a hybrid as well. So this is going to walk you through different areas as well. And the labs are included as part of this. Now, if we go back here to the Qwiklabs, we could go down here and take a look at the different labs available. And if you see here, they have infrastructure and DevOps. And this is Google Cloud, for example, over here. I could go down here and look at others like GCP Essentials. This is a quest again, and this is basically going to show you the labs. In other words, create a virtual machine. And this is going to show you what you'll do in the lab. For example, create a VM, connect to the VM, etc. And you have 40 minutes to do it. And what is actually cool is it actually spins up another instance of Google Cloud Console, so you don't have to use your own credits or your production environment or whatever to learn. So with that said, this is Qwiklabs. Go over to qwiklabs.com, and it's actually spelled Qwiklabs.com. Let's go ahead and move on to the next module. Now, there's a really nice resource that Google has put together called DevOps Solutions. And the page to get there is essentially cloud.google.com/solutions/DevOps. Now, this page here, they put together essentially some DevOps guides that you go and look at different types of solutions to deploy around DevOps to help enable your organization be rapidly deployed on Google Cloud around DevOps and whatever requirements you may have. So for example, there's DevOps guides over here that you could look at around setting up Jenkins or continuous delivery to Kube engine using Jenkins, or Helm, for example. And as you can see, there's a good amount of choices that you could look at to determine what may help with your deployment or training or just interest in DevOps. Again, it is over at the Google Cloud Solutions/DevOps website that you'd want to go to. With that said, let's move on to the next module. There is a really nice resource for those that are interested in learning more about Google Cloud and actually putting together diagrams of Google Cloud services. Now, what you want to do is go over to the cloud.google.com/icon website, and this will bring you over to essentially what is a bunch of different types of formats for putting together diagrams. With that said, there's Google Slides and PowerPoint and Lucidchart and some others that may be of interest as well. If you want to go view the slides, you go ahead and select those as well. But basically, these are diagram examples of different solutions. Now, when you select the PowerPoint, for example, it's going to go ahead and pop up the PowerPoint for you to download. And basically, that will be there for you to download when it is available. Now it's available, and I'm able to open it up. And you can see that it's got a table of contents. There's a good amount of pages available. But the main thing to show you here is if you just go through it, you'll see that they're going to have a fair number of examples to look at and how to put something together. They have icons that you could utilize as well in your diagrams. They have the different services that you copy and add as well to make it look as neat as possible. And what's really nice is that they give you examples of how to put together a service. For example, how do you configure a mobile back end? And what services could you use? Like in this case, Cloud Endpoints and App Engine. This one could be Compute Engine. And this is a little bit more complex in the sense that they have cloud storage and Cloud SQL. And there's over 80 plus pages that is part of this download. Go over here and you can see that we, for example, here have a time series analysis. This is continuous delivery with Spinnaker services and how something could be set up with different services like Compute Engine and load balancing, for example. And lastly, if we scroll down here, we also have some other diagrams that might be useful. To the right subset, like, for example, big data. time series analysis, how to process logs with Google Cloud, what services could you use. With that said, this is called the Google Cloud Platform Icon Library, also known as the Google Cloud Asset Library as well. Let's move on to the next module. Now, when it comes to certifications with Google Cloud is certainly building up their portfolio of available certifications. So what I like to do is talk about the available GCP certs at the time of writing, and then compare them to AWS. So currently we have the Associate Cloud Engineer. This is our day-to-day, basically, operation of our cloud. Cloud Architect is really meant for someone that's in pre-sales or designing cloud services for an enterprise. The Data Engineer is really all about deriving value, a lot of big table, BigQuery questions around that. The Developer, this is the one you probably want to consider if you're a developer developing apps on Google. This is really the cert to go to at the time. There currently is no DevOps cert as in AWS, for example. And then we have a network engineer and a security engineer certification. And lastly, there is G Suite, which is your email and collaboration certification. Now, when we compare, for example, the cloud engineer, we want to look at the AWS SysOps, associate as being as closely related as possible. The cloud architect is really a combination of the AWS Solutions Architect Professional and the AWS Security Specialty. The data engineer is a combination of the DevOps Professional and Big Data Specialty. And then lastly, the Google Cloud Developer is really, when we look at AWS, a combination of the Developer Associate and the DevOps Professional as well. So I hope this helped you out. I hope the course was useful. I wish you all luck on your DevOps journey in Google Cloud. With that said, I want to thank you for joining. If there's anything I could do, feel free to reach out on LinkedIn.